Okay, welcome everyone to the first of our breakout sessions. Welcome also to the people in the live stream. So this is a live stream session. So to make any questions to the speaker, you should join that QR code that you see there on slido.com. And you will be able to type your question, and I'll relay the question at the very end. So we will have enough time for questions, so don't be shy. Just type away. For those on the live stream, same thing. So you will be able to see a link pinned on the channel. So use that link to ask as many questions. We want to make sure that this is inclusive for people who are watching the live stream. So ask questions, please. Our first speaker today is Eduardo Serrano. So he's an infrastructure manager at T-Conecta, part of Grupo Bimbo. He has more than 20 years of experience in the technology sector with specializing in infra, cloud, and observability. And he will cover how T-Conecta helps small shops in Mexico to digitize their business and how Grupo Bimbo is able to manage everything from a central location, processing more than 500,000 transactions per day. So please, big round of applause to Eduardo.
Thank you, Ara, for this presentation. Welcome, everybody. I'm very proud to be today here to share with you how we are implementing observability tools for nourishing a better world and for preventing digital health in our business. So let me make a little introduction about Grupo Bimbo. Grupo Bimbo is a Mexican company that is a global leader in the bakery industry. We have presence in 3-4 countries, and we have more than 1,100 brands and more or less 9,000 products. Maybe you consume some of the products here in the United States. One of the stars products now is Takis. Takis is one of the stars right now. So in Mexico, one of the principal distribution channels for Grupo Bimbo are the little stores. This little store in Mexico we call tiendas or tienditas. So it's a very important business for the Mexican society. These little tienditas are located in the neighbors and had an important social cohesion role for the Mexicans. So this small business in Mexico sell basic products for the Mexicans, milk, eggs, and other products, and are located in the neighbors. Are a very trustworthy business because the most of these tienditas are a familiar business, and the people trust in the owner of the tienda, and the owner of the tienditas know a lot of people on the neighbors. More or less in Mexico we have 1 million of this business, and economically, this business generates 1% of the gross national profit. So it's a very important part of the economy of Mexico, this business. But in the past years, in the recent years, this business have a lot of challenge. First, because a lot of supermarkets or convenience stores are located in the neighbors. So these supermarkets have a lot of services, digital services like pay with credit, debit, and other digital services that the littlest business can have. So if no digital services, well, it's a big competitive disadvantage. And if this business are in the competitive disadvantage, well, they have a low profit. And if they have low profit, maybe they need to close the business or something like that. So it's a very, very important for Grupo Bimbo to help to this business in order to they can improve the profits and stay in the market. So how we can help? How we can help to this business to do the best? The idea was create a technology-based platform to provide digital services to these tienditas and help it to be more competitive and stay in the market. So Grupo Bimbo acquired T-Conecta in 2018. T-Conecta was another company from born at 2009, I think so. But in 2018, Grupo Bimbo acquired the total of the company, and then T-Conecta is now the 100% digital platform from Grupo Bimbo, which is focused to creating a value to the storekeepers. How we do this? Well, first, we have access to our digital services for these little stores in order to increase the service catalog. What digital services? Basically, they can receive pays from credit and debit cards. They can sell prepaid airtime for our cellulars. You know, in Mexico, more or less 18% of the cellular market is a prepaid plan, no a postpaid plan. So it's a big market for the sell these recharge of the trans for the cellulars. The other services is the availability to pay bill services like electricity, internet, satellite TV, and other services. So the people can go to the tienda and pay the electricity, pay the internet, and pay all these of services. And what happened when we put in the hands of these stores these digital services? Well, they have increased the sales more or less up 30%. Why? Because we have now crossed sales. What happened when somebody goes to buy the milk? Maybe, now I need to recharge my cellular. So they recharge the cellular. Or vice versa. If they go to recharge the cellular, they think, I need a meal for my house, and they buy the meal. So we now have crossed sales for the stores. The other thing is the reliability to tracking all transactions. Our platform is a very, very trusted platform. So we can track the transaction from the beginning to the end of all the process. So the owners can trust that we are the correct work in all the process. And we have access to another digital services exclusive for our Bimbo clients. Okay, what we have? We have this kind of dispositives. We have one mobile application available for Play Stores and Apple Store. We have a little card reader who has a Bluetooth connection in order to pay with credit and debit cards. And we have a little smart POS terminal. The POS terminal have an Android system inside, and they can offer this product. We build the platform 100% in the cloud of AWS. We don't have any on-premise service. All our platforms are in the Amazon cloud, and we all make the wall integration, the cloud with the Datadog platform. That is some screens that our application. We have the sales, our time sales, the bills, services bills, pay, and paid of the credit and debit cards. We have a lot of carriers in order to offer a big catalog of products like Movistar, AT&T, and other Mexican carriers. We have a lot of service providers, Telmex for telephone, Sky for satellite television, and others. And we have the availability to these stores can order the Bimbo products through our platform through this marketplace functionality. So they can order the Bimbo products through the application, and the order goes to the distribution center, and the distribution center send the product. And we have other services exclusive for the dealer tenants. The last of the one of them is Fiado. Fiado in English is like a credit. So the owners of the stores can give little credits to the people, little credits, 100 pesos or something like that, and then make the annotation in the applications for this person's have a credit of 100 pesos, and the application sends a SMS message to these people saying you have a debt with the tiendita for 100 pesos. And when this client comes to the store and pays the debt, the application sends a message saying you don't have any debts. So that little functions help the owners to manage the business. Okay, let me explain a little how the model works. We have a prepaid model. And this model, our clients need to prepay the balance to our accounts. So all merchants have a T-Conecta account. In this example, the merchants deposit 100 pesos to the T-Conecta account, and we put available the balance in their account. So when the merchants sell a product, they have a little discounts for the products. So if they'll sell 100 pesos airtime recharge, we only discount 95 because he have 500% of discount. So in this model, we manage the money of the stores and offer different discounts. It depends the service. So it's very, very important for us that this platform are very, very trustworthy, because we have the money of the business. And if we have the money of the business, it's very important that nobody lost the money, okay? So in this way, we're thinking how we can ensure a digital health. The first thing is, what for us is a digital health? Digital health means for us, make sure that all the components of the platform work optimally. It's a constant health check for detect and correct issues, a constant health check. So we think if we need to have a constant health check for our platform, we need a tool who permit us to make this monitoring and this observability. So what is more important in this way? The first thing is the availability of the balance of the account. If the owner of the business put the money in the account, they need to have this money availability all the time. All the time. For this business, time is money. If the platform is down, every minute the platform is down, we lose money, and the business loses money. So it's very important for us, the availability of the balance. Second thing is the availability of all the platform. This is a platform 24 hours over 7 days, over 7 days. In the last quarter, the availability of the platform was 99.93%. It's a very good availability. And the third thing, the reliability. Needs to be a very trustworthy platform. Needs to be a very trustworthy. We need to prevent the frauds. We need to ensure that the money of this business are sure. All transactions are very, very trackability, and we can know what's happening with the transactions. So the first thing that we do is create a dashboard for each service. We can monitor each service minute per minute. In this dashboard, we have a lot of services like Telmex and other services. And if you can see the blue line are the success of transactions, minute by minute. And we have another red and yellow lights. That means I have some kind of problem with the service. So we can see in this graphic what is happening with the service at the moment. If a service have a problem, we have a graphic line to say, tell us, hey, watch out, here is a problem. Let me see an example. And this service is easy. Easy is for a satellite or cable television provider. You can see in this line, the red line show a problem with the platform. And in the description, we have the success transaction, but we have a message that means maintenance in progress. Mantenimiento en progreso means maintenance in progress. So what some happen with this service at this moment that we have a problem. So the teams can make actions in order to restore the service immediately. Maybe the problem is the provider, we don't know. Maybe the problem is our platform, maybe the problem is the application, maybe the problem is the communication, we don't know. But with this dashboard, we can see what is happening with the platform. We build this dashboard based in logs. We ingest a big quantity of logs to the platform. More or less, we are ingested 2 terabytes of logs per month, so it's a big quantity of logs. But now we are working to index the logs, to make the analysis of the logs, and well, we know the keynotes today. We have a very new Flex Logs tool for this thing. We have a log improvement because at the beginning we start ingesting all the logs to the platform. A lot of logs. We are lost in logs. We inject logs, but that is not the right way for us. So we need to remake the solution for logs, and that solution is we put a central logs repository. So all components send the logs to this central repository, and this central repository filter the logs and send only that we want to the Datadog platform. This help us for 2 things. One, because we can filter the logs before they go to the Datadog platform, and the second is for the rotation. In Datadog, we only have 7-day rotation, and in this log repository, we have 1 year, 2 year, 3 years retention for the logs. The other thing that we configure is the monitor configuration. We have more or less 45 monitors. We have more, but basically we have 45 monitors. We monitor each service visually, and when a service has failed, we have a red color right here and email notification for the teams. So we can now, at the moment, what service is failed. So it's not only for the IT teams, because we now send a push notification to our clients, and the push notification sent to the application, and we can say, oh, sorry, but that service have an error, we are working to restore the service very quickly. And the clients know what is happening with the platform. And they can know that they can sell this product at this moment. And when the service are up again, we send a push notification for tell, okay, the service is okay, you can keep selling. Okay, this is a very, very important part for us because in the notification configuration, we are transitioning from reactive to proactive notification because we want to prevent the health of the digital platform. So we need to be more reactive, more proactive, not reactive. So now we can know when something is happening. In this case, this notification is for latency of the one services. So some happened with these services, but the latency was increasing, and we immediately have a notification. And then we can know, find the problem, not only in the application layer, but in the infrastructure. Maybe the problem is in the CPU, maybe the problem is in the database, maybe the problem is in the network. So we can now find the problem in all the components. It's very important for us because it's a proactive notification, not a reactive notification. So now we have making another dashboard like an infrastructure health check. We have all with the Amazon instance right here, and we can see what's happening with the CPU, what's happening with the network, what's happening with the memory. We have the database health check, but it's very important for us to see what is happening with the databases. And we have this monitors from the infrastructure of the database, but with the database, what happened with the queries, what happened with the, how many requests, how is the latency, average, and all the data of the database. We are implementing the application health check too. So now we can see what happened with the APS and the application layer. So we can now, what is happening with the network at the moment, with the infrastructure at the moment, with the service at the moment. This is a map of network. It's a little complicated, but we can now track the network traffic too. So what is the important thing of this? The important thing is now we have a wall visibility of all the platform. We can go across components. I mean, EC2 instance, RDOs, a database, load balancers, firewalls, etc. And we can see across the layers, network layer, transport layer, security layer, application layer. So now we can observe all the panorama. If we have a trouble, we can see what's happening in the infrastructure and what's happening in the application, in the network, in all the layers. And most important thing is we can prevent what is happening with the platform. In the past months, we are preventing a lot of incidents, database incidents, application incidents, only with observe the correct things in the platform. This is a very funny example, but it's a real example. Now we have a prevention in atypical or seasonal events. Believe it or not, we have a very increased transaction in these events in Mexico. Mother's Day. Everybody in Mexico loves the mother, and everybody wants to send a message, to call the mother. And when it's a Mother's Day, we have an increase in the number of transactions, basically in the airtime transactions. Earthquake, you know, Mexico is a earthquake country, and when was a earthquake in Mexico, everybody wants to text your family, hey, I am okay, I have no problem, and the sales increase. Social network downs. This graphic is a real graphic from the last WhatsApp down. I don't know if you remember, in July 19, we had a WhatsApp down, and the transactions for the cellular recharge increased. Why? Because the people think they don't have a data in the cellulars. So oh, what's happened with my data? I need to buy another recharge and go to the store and buy the recharge. But the problem is WhatsApp is not working. And other providers promotion. But what is important in this thing? Because now we can track the increment of the transactions, and we can ask to the teams, infrastructure teams, database teams, application teams, to be very, very, how do you say, how do you say, pendiente? Pending, thank you. To be pending of the part of the platform. So we ask to the teams, we have an increase of the transactions, please, infrastructure, check the CPUs, check the network, check the RAM, database, check the queries, application, check the services, and everybody put the eyes on the services. Maybe nothing is happening, but maybe we need to take an action. What happens if the CPU of one instance are increasing too? Well, we can make an increase vertical or horizontal or vertical of the instance. Fortunately, in AWS, we can make this very easy. So we can take actions over these events, and we can avoid all the platforms comes down. So now, with all their actions, for us, we can make the merchant happiness path. What is a merchant happiness path for us? To resolve the first things, account balance availability. They have the money available all the time. They can sell, if it's the morning, if it's the evening, if it's the night, they can sell and they can have the money available. Second thing, the platform availability. If we can avoid the download of the platform, they can sell and sell and sell and sell. And the reliability, they trust in our platform. They know that we have a problem, we send a message, and they can know when the problem is resolved. And the most important thing, the profit increase. If they increase the profit, they can stay in the market. So for us, the preventive digital health means the clients are happy with the platforms, and the clients are happy with the things that they can do with our applications, and because they are given the money. Okay, other group of Bimbo projects that we have on the observability, this is a very interesting, is Autoven. Autoven is one of the largest operators in Mexico for vending machines for snacks and soft drinks. And now in these machines, we had adapted a POS terminal with an Android application. And now, in these machines, the people can get the snacks, but then they can buy airtime, they can pay the bills in the machine, and they can, all the services of the little tienditas, they can do in these machines. What is the advantages of this, or the benefits of this project? Now, these machines have an instant telemetry because the terminal have a cellular SIM. The cellular SIM are connected to the network, and the machine are sending the telemetry of all the time. So now we have eyes on these machines, so we can make a UX monitoring, and the most important thing, improve the control. If we can improve the control, we can improve the quality of service. This is our dashboard about AutoVen. We can know how many machines are working in the day, how many cash transactions, how many credit card transactions, and some important data is how many not the library products machines we have. You know, with this machine have this spiral, you put the money, you are waiting for the chips, and the machine is going, and then stop. And you, oh, what's my product? No? So we can know how many not the library products have. So we can know what machines have a trouble, and we can send technicians to look what is happening with this machine. So where we are, we have observability in more or less 17% of the platform. We're implementing new features on the platform like ASM, cloud security management, cloud host, logs. We want to migrate from logs to traces and metrics, and we are working to implement synthetic test. Our recommendation about the best practice to implement the observability tools. The first thing is become proactive, turn on data logging, filter the data, build holistic insights, integrate observability tools, of course Datadog is the best, and create contextual reports. In conclusion, the best way for us to improve the quality of a service is to know that this service works correctly from start to finish. Prevent the digital health for us goes beyond technology, because in this case, we are talking about the tienditas, we're talking about the families, we're talking about persons, we're talking about neighbors. So it's very important for us, not only the technology, but the people that is involved in this business. So if we can add value to this business, we can get the opportunity to increase the income, and the most important thing, to remain in the market. And for us, if we are working they and us together to nourish a better world. Thank you. I don't know if we have questions.
Thank you. Thank you, Eduardo. That was fantastic. Can we get the next slide with the QR code for the questions? No, the first slide, like the first slide. Yes, like the very first one. If anyone wants to, just to get the QR code there to get questions. Thank you. Yes, so we have several questions, but you have the QR code there if you want to ask more. The first one would be, did you measure the acceptance ratio of those services in the stores? What are the main blockers to increase the penetration?
Okay, can you repeat?
Yes.
Can I read it?
Yes. Did you measure the acceptance ratio of those services in the store? So how many tienditas didn't go through?
Well, Grupo Bimbo have more or less 100,000 tienditas, but not all of these tienditas are our clients. Maybe we have 13,000 tienditas.
Sounds good. And similar to this one, how do you train the owners of these technologies?
Well, we have a very big team or sales team. The sales team are in the streets and go to these tienditas and show to the owner to how to use the application. It's a very strong team of people goes to the streets and go to all this business and install the application on the cellular of the business or install the POS terminal and take the training to the owner.
Basically one-to-one training.
One-to-one.
Fantastic. Related to observability, are you able to effectively monitor all the diverse devices and clients you support? For example, the card reader, the smart POS terminal.
Not for all the models of the terminals, because we have some models are very, very old, but we are available to make this for the new models, yes. We know the carrier of the SIM of the terminal. We know the serial number. We know what is happening with the memory of the terminal and some things. Not a lot, but some data of the terminals.
Okay. Do you have any plans to bring this to different countries?
Yes, but we are focused right now in Mexico. We have a little pilot in Brazil, but the goal market is in Mexico City, but now.
Sounds good. And we have just one last question. I'm sure this is coming from this room and not the live stream room, because someone asked if you brought any Bimbo pastries.
No, I don't. It's the second person who asked me this one, but sorry, I don't. But you can go to the, to the Target right here. I promise you I can.
Good. Thank you very much, Eduardo.
Thank you very much, everybody. Thank you. Thank you, Datadog, for the invitation.
I'm Stephen Fry. I work for the London Stock Exchange Group. We are a leading provider of financial markets infrastructure and data services. The London Stock Exchange Group is historically around 300 years old, so it's had to continually transform and innovate. Datadog helps us innovate by giving us insight. It's as simple as that. You take all of the data that you can possibly get from an application, you learn as much about it as possible, and you consume and bring that data together in a way that's meaningful so that you can create a better customer experience and a better service. The biggest risk for us, being a financially regulated firm, we're systemic. Because we're systemic, the challenges that we face today are that if the infrastructure goes down or is faulty, the impact is immediate to the market. We've had experiences where an announcement comes out into the marketplace completely unexpected, and suddenly the website hits just go through the roof. Instant impact on obviously the performance of the website, and Datadog monitoring enables us to see that before the customer sees it and to take action and do something with it. If we see problems with the website, we can then act on that using AI operations. We have trigger events that go off and fix problems, or they might scale up the website because of the usage increase. Before we used Datadog, we had sparse information about the workflows and the processes that were going on around our trading applications. With the introduction of Datadog, we've now got masses of data points that give us insight about the application, and that enables us to take it back into the development cycle and improve the service so that our customer experience is much, much better.
MyFitnessPal is the world's most comprehensive and trusted nutrition insights platform. We have 200 million subscribers that use us to gain insights into their nutrition and wellness and help achieve their own personal health goals. At MyFitnessPal, we try to think about the health of our platform in terms of the customer experience. This is one of the key philosophies of site reliability engineering that powers forward SLOs, measuring success from the customer's perspective. One of the most important times of the year for MyFitnessPal and our business is what we would call the New Year's rush. We can't provide good customer experience if the platform isn't up, if it's not available, if it's not performant. Monitoring of observability helps us ensure that the platform is available and performant. Datadog provided an interface for us to inspect the state of our system, from our EC2 instances to our backend databases, and how our individual applications were performing. Thanks to Datadog, we were able to spot several performance issues in specific applications and quickly address before they turned into customer happiness tickets. We had one of the quietest on-calls during our New Year's rush that we have had in previous years. With Datadog, what would have been a stressful experience with a lot of digging, that's turned into a streamlined response process where any on-call engineer, whether they're new to the process or they're seasoned, can quickly diagnose the root problems. We're no longer having to maintain our own observability or telemetry platform, which frees us up to focus our efforts on other types of innovation to help empower our platform. And our on-call engineers have a standard interface that they can use to share dashboards, link metrics, alerts. At MyFitnessPal, we're excited to continue our partnership with Datadog as they empower us to provide the best customer experience we can for our subscribers.
What if you could know exactly what is changing in your applications and infrastructure, how it's impacting your users, and what to do about it? All of this continuously and in real time. Enter Watchdog, Datadog's fully automated AI engine. Without any setup, Watchdog provides automated alerts, insights, and root cause analysis. Watchdog draws from observability data across the entire Datadog platform, so you know exactly what's happening in your infrastructure and applications at all times. The more telemetry you send to Datadog, the smarter Watchdog becomes. By continuously monitoring your infrastructure, Watchdog can quickly spot unusual activity. Here's how Watchdog Alerts works. As soon as issues arise, Watchdog Alerts automatically brings anomalies, failures, and inefficiencies to your attention before they affect your users. This jumpstarts your investigations and helps you reduce your mean time to detection. During investigations, Watchdog Insights sifts through your logs, traces, and RUM events to surface the outliers that matter the most, enabling you to quickly determine the next steps and get closer to remediating issues. With root cause analysis and business impact analysis, Watchdog gives you answers for fast, effective resolution. Using data from APM along with metrics, traces, and logs from your entire system, root cause analysis maps critical failures to their root causes, calculates their effect on other services, and speeds up the resolution process by providing actionable steps. Additionally, business impact analysis works with RUM to help you evaluate the full impact of an incident. You can quickly identify the affected services, users, and views across your web and mobile apps. Watchdog Alerts, Insights, and Root Cause Analysis monitor billions or trillions of records in real time, helping you separate important signals from the noise and proactively address latencies and errors. You can leverage the power of Watchdog throughout the Datadog platform, from infrastructure monitoring and log management to APM and RUM, with no extra setup required. Get started with a free trial of Datadog today to see the power of Watchdog in action.
Hello, everyone, to this second breakout session. We are on live stream as well, so welcome to the people who are watching on the live stream. For Q&A for these sessions, how it's going to work is there is this QR code on the screen that you can scan or directly go to slido.com and type your question, and I will relay the questions afterwards in order for the people in the live stream to be able to participate in the Q&A as well. So our next speaker today is Toli Apostolidis. He's a principal software engineer at Flipdish. He's super passionate about observability and how observability can improve how digital products are run in production. He's also very keen on domain-driven design, wordly mapping, and team topologies. He also played basketball semi-professionally and was on the Greek national team as a under 16. And he was also a speaker at Dash 2021, so it's the second time that we have him here. And he's here today to tell us how to build a culture of observability across your whole organization. So please, big round of applause to Toli.
Thank you, Ara. That was a very kind introduction. Thanks for everyone for coming to my talk. This talk is, as Ara said, I was at Dash 2 years ago in the midst of the pandemic, and back then that talk was about our story, our kind of transition to serverless, the company I used to work for. This is more about the lessons that I learned over the last 4 or 5 years in building a culture of observability in an organization. And hopefully you might take some tips and tricks of how to establish a culture of observability at your organization. I'm assuming, because you're at a Datadog conference, you're accepting that observability is a core practice and that you want it to be a bit more widespread in your organization. So, one second. Yeah. So, and then also I might give you a bit of a hint or an insight of why I think democratizing observability is a thing, and why Datadog and all the other vendors, I think, are moving towards that direction. But first I want to give you a story about observability in biological systems, and in particular in human cells. I was talking to my partner about observability in software systems, as you do. She heard me a lot in calls, so I had to explain a bit what observability is. So I asked her, how do you in your field observe biological systems, your human cell? How do you find the Wally in the trillions of different components in the cell that interact with each other all the time? A very, very complex system. So she explained to me that you can take various laborious and time-consuming biochemical and biophysical techniques to extract, to isolate the little Wally, the little component that you want to study. And if you're lucky, after a few iterations, and actually after a few years, you might find your Wally. You might find your isolated protein that you can actually study. And this is great, but it takes a lot of time. The lead time is high, and it doesn't guarantee success either. So the second way that's suggested to talk to me about was this process of tagging. So they re-engineer the DNA of the cell so that they can color code different types of components within the human cell. So they use blue, red, green. And that way, with that very elegant and simple technique, once they subject the cell with various different experiments, they can actually observe what's happening in the cell in the context of the human cell, not in isolation. And that's a massive win, as we know from software systems as well. So I found this fascinating, so I thought I'd share that as a first story for this talk. By the way, my partner is a postdoctoral research fellow in synthetic biology, so she knows this stuff, so that's why I was asking her. But I'm Toli. Ara's made the introductions already, but I'm half Greek, half British. I work for Flipdish, which is a company that works in restaurant tech. But previously I worked for a company called Cinch, which is an automotive car seller online, and that's where I got most of my insights about observability. To be honest, when I first started out, before I started out in software, I would never have asked my partner these questions. How does this cell work? How does the software systems work? I really, really didn't care. I studied maths and mathematical physics, less than mathematical physics, but more on the pure maths. So I really didn't care about any of these concepts. But then I got hired as a software engineer in a company that was building algorithms to solve the traveling salesman's problem for large-scale problems. So I couldn't really tell that I was a developer for about 2 or 3 years. I felt as a real imposter. But then I started getting a bit more confident, and I thought I could do this really easy. I got another job. I worked for an energy company. They had actual customers rather than the B2B that the previous company had. And within the first 1 or 2 releases, I broke production. And I mean, I don't know, just a show of hands if you've broke production ever in your life. Yeah, very good. So it's a common thing. But it was very stressful. And that's when I started reading up concepts like DevOps and kind of catching on those movements that I'd missed out on. That's around 2017. But I also came across this concept called observability. And as Ara was saying earlier, I became very passionate about it. And the reason was it started unlocking potential to handle production systems a lot better than I was used to. So you might wonder, why am I here? So it's all good, but what is my main point? So I've got this thesis that the more observable our systems, the more democratized our understanding of our software systems across the organization. So this talk is evidently about observability. So before I move on, I want to give a quick definition, or at least how I think of observability. And this is a definition from the Observability Engineering book by charity majors Lace von Jones and George Miranda, where they state, amongst other things, if you can understand any novel state without needing to ship new code, you have observability. So it's not about you have an incident, that incident that I had in the energy company, and then we add logs after the incident. You can do that, but with observability, you have that capability already. That's the big difference. And if we break it down, observability is not a verb. It's not something you can do. It's a property or characteristic of the system. You can explain any bizarre or novel state, but critically, without shipping new code, but without predicting any state. So you don't need to, like we do with testing, predict what might happen. You do it in a way that it's more systematic and methodical, and you can answer any questions on the other side. The second point I want to make before I kind of move on is, it's not another fad. It's not something, I don't know, there are, say, LLMs, for example, they still have to prove themselves, or blockchain. Observability, in my opinion, is here to stay, and I want to give you 3 arguments of why I think that. The first one is DORA. So again, quick show of hands. Have you heard of DORA and know what DORA is? Great, perfect. I'll give it a quick definition. So DORA has been a long, years-long, almost decade-long research program on DevOps maturity. So they send out assessments every year to thousands and thousands of people and organizations, and they assess the maturity of all the companies in DevOps maturity, and in DevOps, sorry. And Accelerate was a particularly amazing moment in the DevOps movement, because it took DevOps from a hip movement to an actual mainstream, we should all do DevOps. Because they proved that, I think I've got this in the next slide, using these 4 metrics, you can measure DevOps maturity. So how many times you deploy to production, what's your lead time to production, how many times does that deployment to production fail as a percentage, and how long does it take you to restore that service? If you're doing well in all these metrics, you're doing well in DevOps, but the critical thing that Accelerate proved, that there was a predictive relationship between elite DevOps maturity and company success. So you make money by being good at DevOps. So that was pretty powerful, and everyone's really excited. But then in later assessments, later years from 2018 onwards, they started seeing a 5th metric emerging in reliability. And you might be wondering, why am I talking about DevOps when I'm meant to be talking about observability? This is when observability comes in, because they're starting to find that it's not enough to deliver well, you also need to operate reliably too. And a lot of things go into reliability, but observability is one of them. The second point I want to make about observability is that increasingly teams are building, shipping, and supporting their own software. And although we've got really good at building and shipping, we've got, it's really hard to support your own software, especially if you're a developer, especially if you're a cross-functional team. So observability is a key capability that can help you do this. And the third thing, which might be obvious, but we often overlook this, is that systems are complex. Probably for good reasons. We have distributed systems, we have microservices, but they are complex, and they're hard to fit in one person's head or a team's head. This is an actual service diagram of all the services at Cinch, where I used to work. And it's really, really hard to find Wally on the bottom left there, because there's a lot of things going on here, and it's quite complex. So having good observability will help you. So hopefully I've persuaded you that observability is something that will just increase as a capability across all organizations. There's various white papers out there that indicate the same. But the main point I want to make is how you can establish a culture of observability. So it's sort of easy because you're at Datadog already, so that's the first step. But there's 3 steps. You choose your observability tool. You might choose Datadog. You enable your telemetry data, as we saw in the keynote earlier. It's a lot easier to enable all the telemetry data, enable all the traces. And then auto-generate the dashboard, which Datadog does for you really well, and then you're done. So I'm happy that a few people laughed, because the key takeaway, if you take anything out of here, is that you can't plug and play an observability tool. You can't buy an observability tool and just give it to people. You're wasting money, and I might say this a few times, it is expensive. So it's not really about those 3 things. But what occurred to me after a while of working with teams and people and trying to persuade them that they should be considering observability is that observability is the testability of the 2020s, but in a way better. Because what I mean by that is tests tell you what's broken, whereas observability tells you what's happened. So what's more important, what's happened or what's broken? And critically, the broken bit is you know about it in the isolated lab testing on your laptop, on non-prod environments, not on the kind of widespread field testing that we do observability in the actual production systems. Another way of looking at it is there's this really, really good book called Thinking in Promises, and it's all about how you look at software systems as agents that make promises and how the other agents interpret those promises. So if we ask ourselves, what promise are we keeping with testing? Well, a promise that will change the software and it won't get worse. If anything, it'll get better. That's something that we're trying to keep with tests. With observability, we're saying that I promise you will have a service and you can rely on me. If I make a change, I promise that your service will get better and I will know if it doesn't. Again, it's probably more akin to reliability here, but observability is the key to knowing whether you have reliable systems. And this is a nice diagram. I'm sorry to kind of use your hands again, but a big show of hands if you've seen this type of diagram before, the unknowns and yeah. So this is very popular in the observability space. There's the y-axis being level of awareness, the x-axis being level of understanding, and testability in a way enables things that we are aware of and understand, whereas observability unlocks this potential of things that we're not aware of and don't understand. So we can be very curious and understand and figure out things that we never ever expected. So I hope I've kind of set the scene a bit. And now I'd like to say, well, what do I do? Well, the first thing to understand is that what we're doing with observability is we're creating and curating our telemetry data to enable observability. Again, it's not just plug and play. We need to think a bit more consciously about what type of telemetry data we're creating. So where do I start? So I kind of said that there's no 3 things, but if I look back, there are actually 3 things that I figured out that are the most useful. So yeah, you do have to pick an observability tool, but critically, you have to let everyone have it. You need to instrument your code, and you need to support and enable learning, the third one being the most important. But if we start with the picking observability tool quite quickly. So the first question, sorry, that you might want to ask is, well, how do I choose? How do I choose an observability tool? And I know we're at a Datadog conference, but just to give you some heuristics in case you want to look around. The first thing is, can everyone use a service with no extra cost? If you want to enable everyone in the organization to use this tool, they can't have barriers for entry. An example for barrier for entry is GitHub. GitHub is seat-based, and a lot of people can't get access, like non-techies, because it costs more. So that creates silos, unintended silos. I don't know of any observability vendor that has a seat-based rather than like ingress of data billing model, but you have to bear that in mind. Second thing is the developers are going to use this tool. You want them to use this tool, so you want the observability vendor to have excellent DevX tooling. And that's really important. Your SDKs, your traces, that kind of stuff. It needs to be really, really good. And you need to enjoy when you use them. Third heuristic, is how far can you get without checking production? And what I mean by this is, I see the cloud providers, for example, Azure, AWS, Google Cloud, as the operating platform. I see the observability vendors as your understanding platform. So you have your understanding platform, you have your operating platform. You shouldn't have to log into your operating platform for various reasons, for security reasons, for avoiding ClickOps, all these things, but you should be able to understand what your software systems are doing through your observability provider. And the question is, does the one you're going to choose enable that, or do you have to then switch between cloud providers and observability providers? And finally, it's probably the most important one for a lot of people, especially if you're a decision maker in your organization, is can you manage billing effectively? Traditionally, from my experience, the billing is not transparent, it's not easy to manage. There's various mechanisms that you can use, but it's not as easy. You need to learn a lot. It's a steep learning curve. So that's something that you need to look at when you're looking at observability vendors. Then I just put a few examples. I've classed them as established, so your Datadog or your Dynatrace, that type of organizations. Your startups, which is kind of newer generation observability vendors like Honeycomb, or more specific observability vendors that, in my case, I chose serverless because in my previous organization we're entirely serverless, but you'll find these niche observability vendors that are a bit more specific. So Lumigo is an example for that. So that's it with your picking your observability tool. The second thing that's important is instrumenting your code. And I don't know, has anyone here before heard about instrumenting code? Put your hand up. Yeah, so quite a few, that's good. Good. So I just added some pseudocode here of order placed. So this function responds to an order event and has some business logic, but the important bit is it has some tags, order ID, user ID, order placed. Because instrumentation is the practice of systematically configuring your code base to emit telemetry data. Because then it provides insights into how your code is exercised by data in production. That's my definition of instrumentation. But once you instrument your code, you get the ability to diagnose problems, you get the ability to learn how your software is used, you get the ability to get ideas, potentially, from how your software is used to improve it. So learning how to instrument is important. So this is your developers in your organization. They need to learn how to instrument like they know how to write tests. Because, and also a lot of the developers know how to do logs. But logs in this kind of diagram, again, are probably more akin to the known knowns. So you kind of know it's happening. You write the log, you send it to Datadog. Whereas with tags, you enable these unknown unknowns. Here's an example. So with a log, you can say an order was placed with order ID XYZ. But a better way to do it is to add these tags that you saw in the earlier example. So order ID, user ID, order placed. You're building a data set of useful attributes that you can then query, rather than a list of free text, even if that's a structured log. And the way I tend to explain is you have to think of every input, output, or parameter in your code as an opportunity to learn. Your code is going to be in production, it's going to be exercised by users. What can you learn at any line of code? So these are your opportunities here, because that's where your users are. That's what happened. This is not in isolation from the people who use your software. But you can ask any question. This is why it's so powerful. So you can say, select star from order event. where user ID equals X, if that's what you want to ask. Or you can say, select star from order event where order placed is true, and get those answers. But you don't need to know ahead of time what questions you want to ask. You don't need to go and look at the code and see what the log is and where that log is, and then correlate the two. So in summary, on the instrumentation, I would say that you have to do 3 things. Anytime as a developer, you need to be thinking about writing code, writing your tests, and instrumenting your code. And I always put this next slide in because I'm afraid of the TDD aficionado. So like you might write the test first, then write the code, and then instrument. That's fine. Or you can do any permutation of this as long as you do these three things as a standard practice. So that gets out of the way the observability tool choice and giving everyone access to it, instrumenting the code, and the most important thing, my biggest takeaway, is supporting and enable learning, because you won't be able to really have a high observability maturity without enabling people to learn. I saw this very interesting quote by Adrian Cockcroft, and I actually heard it in the Hacking the Org podcast by Charles Humble. He said that you can construct the behavior of a system from its externally visible components. That's what you're doing with telemetry data. So you have this black box. It's giving all this information. You start predicting the behavior of the system, and that's what observability is. But the problem is, how can teams make sense of all this data? How can teams make sense of all this information? And that's why you need to support, learn, and actually practice as well. That's a really critical step. So step 0 almost is to add observability to your golden path, your paved road, the way you do engineering in your organization. What I really mean here is that you have your hosting paradigm, in our case it was serverless, your event-driven, your kind of architecture paradigm, in our case event-driven, or trunk-based pairing, mobbing, TDD, all this stuff. Observability needs to be there alongside all those guys. The second thing that I think is very, very important, you need to plant enablers into teams. You can't sit from far away and say, here's a tool, use it. You have to think a bit more consciously about your org design. In our case, we used automation engineers who were basically software engineers who just had a knack for learning infrastructure as code, CI/CD, observability, and they would sit there and say to the team, guys, how are we going to know if this works in production? And then if they said, well, we won't know, then they started introducing techniques and practices of how they can achieve this. Principal engineers sit outside the core team and support in similar ways. And I'd like to call out the supporters, the service delivery managers. That's what they were at Cinch. But these people are very good at kind of building workshops. It's the more social aspect of things. They can build workshops like service readiness, like what's alarming you, which helped teams understand their P1s and their P2s given the service they were supporting. Really, really important. Third thing that I thought that was really, really important is a community of practice. Peer-to-peer learning is the most powerful thing I've come across in organizations. Often we think about structural training or just self-learning on your own as the best thing, but I've not seen anything more powerful or actually effective than community of practice. We had a community of interest in observability at Cinch, and that actually created some workshops for others, but they created these collaboratively, and interestingly, this was with Datadog notebooks. You can't do any of this without psychological safety, so this is Westrum's 3-culture model. You need to be on the far right in the generative column if you want people to learn. Instant reviews, incidents are a fact of life. They'll happen, so you need to make sure that you're learning from them. That's the first thing you should be thinking about once an incident has been remediated. And remember when I mentioned practice, we ran regular chaos days in teams, but even across teams, and these were really practice days where an incident would happen, and then the team would learn how to respond to that incident. They would learn how to improve their observability. And working groups also started to emerge to create good practices around instrumentation, code instrumentation, and general observability practices. And as a result, we got this Cinch Brew example application, which had documentation and code that demonstrated good practices. And that's it. Those are the 3 pointers I have to build a culture of observability. And the next thing to think about is what can possibly go wrong. And these are signs that I see in organizations, and hopefully I might see some smiles here, or you might be, this might relate a bit. So you've got this, you've got a company where one person knows everything about observability. On the flip side, nobody understands the dashboards. You have loads of dashboards, but no one really looks at them, no one understands them. The third one that I see often, and this is quite an interesting one, is the overuse of infrastructure level metrics. We're so used to monitoring 400s and 500s, which is very effective, but we want to think about more business-related telemetry data, so your orders, the things that are important to your business. And finally, knowing the what but not the why. So a lot of organizations have a lot of alarms coming in, telling them that something's wrong, but they can't quickly understand what's actually wrong. But then on the flip side, when do you know that you've made it? So on the team level, observability is a team responsibility, and that actually does happen. On the individual, observability practices become core skill. They started putting them on CVs and on LinkedIn. And on the org level, all teams practice observability-driven development. And it's akin to testing. So you might wonder, well, why does all this matter? Because, as I mentioned earlier, observability is expensive. Just an interesting nugget of information, our Datadog bill was more expensive than our AWS bill because we're entirely serverless, so that kind of makes sense, but it is expensive. But on the flip side, incidents are rare. We did have incidents, but we didn't have that many. And also mean time to recovery is not an issue. I kind of tried to look for a stat for mean time to recovery, but it didn't really matter because we recovered pretty quickly without much impact. Most of our teams were elite in terms of DORA because of observability. Interestingly, when Datadog had a serious incident a few months ago, we stopped doing deployments because we can't see anything. We can't see how our production systems are doing, so we're not risking anything. So that's how important it was for us. And finally, all the teams had their eyes on production systems. They were testing in production, if you like, if you want to use that phrase. And that is really, really powerful. You started getting dashboards like this, the order squad's motherboard. This is the orders team, and the engineering, product engineering team. They started asking questions, are orders looking healthy? Then, is part exchange service healthy? What changes have we released? Do we have any incidents? Are we seeing errors? And only towards the end, you get, are my APIs healthy? So more infrastructure level questions. At the start, you have all the business level questions. So I started saying that observability is democratized. So I started with this thesis. The more observable our systems, the more democratized our understanding of our software systems across the organization. One thing that I started noticing, and speaking to Ara about this earlier, was observability is starting to eat through the worlds of business analytics and data intelligence, or at least it's blurring the lines. And when I was building this talk, I came across this workshop that was built by BAs for BAs to learn about observability, which is surprising to me. I didn't expect them to be interested in observability. And actually, it finished like this. The observability is not just for technical people. Because understanding of the software is only as good as your telemetry data. That's the thing you'll find out quite quickly. Traditionally, what would happen, you would have your software engineers being your curators and your business analysts being your consumers, with your business analysts saying, can you install this SDK? The software engineers would action it, and then the business analysts would be the only people who would analyze the data. But nowadays, what's happening is that they're merging a bit more. So software engineers and business analysts are curators and consumers together, just like we did with DevOps. Devs have taken ownership of the quality of the telemetry data. And then as a nice result, you get lovely widgets like this, where the payments team at Cinch was actively monitoring single card usage versus multiple card usage. It's an interesting thing, by the way, just a quick aside, that buying a car is an expensive payment. So it takes, you can't typically use a single card because of card limits. So we had the ability of paying with multiple cards, so they knew at any point in time what percentage of users using multiple cards versus single card. The other one that was interesting that I noticed is that they had a funnel conversion in Datadog for finding a vehicle all the way to checkout. And that's a very, there's a very analytics view of the data. It's not just infrastructure here. And also kind of, they always knew what the top model and make searches are. And this is where the users are, and that's what I'm finding really insightful, is that a lot of the non-devs, the non-techies, are actually using tools like Datadog to understand how the users, how the people are using the software. So wrapping up, I spent a few years, and a few other people were asking this question repetitively: how do you know your code is working in production? And as a result, we had 20 plus teams practicing observability like it was a standard practice. I kind of joke a bit, the observability is better than testability. I think it's more, they're complementary, but if you had to choose one or the other, which one would you prefer, production systems working or your non-production systems working? And then these are the three things I suggest to use as a compass of how to start building a culture of observability. When I started out, there was no really good literature in observability engineering. There is since. So I'd suggest reading Observability Engineering if you're interested. If you're not into books, Charity Major is a great person to read her blog posts or her tweets. If you're not into reading at all, listening to a podcast is a good way of learning about observability. But if you do anything, I'd say take observability seriously, but make it work for your use case. I know I've just given you three prescriptive ways of doing it, but this is just a tip. Because if you do, you will amplify and democratize the understanding of the behavior of your software system. And in a way, the way I see it now is that the lack of observability is our collective tech debt, like testing was a long time ago, and we're now improving it. And that's it. Thank you very much.
That was fantastic. This is not the first time that I listened to this, because I sat with Toli on the dry runs, and I found his talk super inspiring. So thanks for sharing. So we have one question on the Slido. So I'm going to ask this first in case it came from live stream, and then if anyone wants to ask questions, just raise your hand and I'll pass the mic. The question is, it's great when an organization has an observability champion, like yourself, but when do you think we will start seeing companies hiring for observability engineers, specifically?
Yeah,
or whether it makes sense?
Yeah, that's a really good question. I was quite lucky that the engineering directors wanted observability. They came to me and said, one Christmas, they said, go and learn everything you can about observability and let's make it happen. On the flip side, that's sort of why I'm here. I'm trying to, I don't know if we have any engineering directors in the room, I'm trying to persuade everyone that the sooner you start your journey on observability, the better for your organization. To be honest, from where I worked at Cinch, we're starting to see people putting Datadog and tracing and all these things and instrumentation on their CVs, and people are starting to take notice, but I think it's very, very slow, if I'm completely honest. And I don't know if it's worth having an observability engineer. I think you would probably call them SREs, but I think my key lesson here is that we did it as part of the team. We didn't have a separate dev and ops, so they were more advocates and enablers rather than doers. So I think that would be the separation. The more we get ops creating the alerts and creating the telemetry data, then the devs will never learn how to be curious and how to observe the data.
Good. We have another question. Well, actually, two questions which are the same one. People they found so many great details in your slides, and they were wondering if you're going to publish them anywhere.
Yeah, absolutely. I'll publish them on my website, toli.io, and on GitHub. I'll share I'm sure we can share them later. Yeah.
Cool. Any questions from the? Yes. Yeah. Wait. Let me wait for the mic for the recording and the live audience and the live stream audience.
So I consumed a lot of Charity Majors' content, and she says that having essentially high cardinality data is the essence of observability. Do you have any best practices for managing all of that high cardinality data within Datadog to relate it back to Datadog?
Yeah, that's an excellent question. So Charts Images is probably the person who coined the term observability, well, at least borrowed it from mechanical engineering, I think. I think my biggest lesson, to be honest, is that you can't take what Charts Images and Honeycomb are doing and apply them to a different observability vendor because they're built differently. So that's number one. With Datadog, I would say that it's a bit different to add custom tags on your spans and do tracing. But I'd say that if you can have traces and custom tags and then generate metrics off your tags, I think that would be my go-to. But at the end of the day, you have to look at your observability vendor and see what they give you, because what Datadog does really well is connecting traces, metrics, and logs. So if you listen to Charts Images, she'll say, we don't need any of these, we just need events. And that works in Honeycomb, but it doesn't work in Datadog. So you have to use what you have in front of you, and it's really powerful to be able to link the three traces. But the thing, I think it goes back to what Datadog says, use unified tagging, service tagging. So always add a service, always add a version, and always add an env, and then a lot of things fall into place after that.
Cool. Well, 1 second. Yes, I'll go back to you. I'll read one of the questions on the slide, and then you go next. So the next question is there more value in having observability as part of a golden path or a separate golden path? Which I'm not sure I understood the question.
It depends who implements that golden path. I think the golden path that I showed earlier was the product engineering teams. And the same teams that built the software, they shipped it, they also supported it. If you have a separate ops department, then you probably want a different golden path. I think that's what the question meant. But if you're in the room, please put your hand up and clarify.
Okay, hey, great presentation. So you gave a presentation a year or two ago, or whatever. So think ahead a year to 2 years from now into another Dash presentation you're going to give. What would you be talking about observability? What would you be adding to it? AI would probably be one, but what?
I'm going to be very cautious to kind of fall into the hype of LLMs. I think one thing that I found interesting in the releases today was the Bits AI. So if we can use generative AI to get more people to look at telemetry data and understand them, so kind of bridge that gap between, oh, I've got this UI with loads of data, how do I make sense of it, to actually make sense of it, that will be really powerful. So hopefully it'd be something along those lines. But the other bit is, I'd say we're still very early stages. So the company I've just joined, they have a lot, so Flipdish are really good at observability, but they have their own unique challenges, which I'd probably say that my next talk would be about that, because every company is different. Yeah, but good question.
And we have time only for one last question. We got one in Slido. So, classical question about the tension between product and engineering. Most times there is an inclination to ship code fast. As a result, observability and instrumentation end up taking a hit. Any tips to get product on board?
Yeah, I do actually. So one of the things that I left out from the talk was we had teams where product owners were looking at dashboards. And actually, although I don't like logs, because as Charts Images probably be against logs as well, but logs are very good for non-techies to look at a dashboard and understand what's going. So they would be the first line of support on things. They would look at the dashboard to understand what's going. They would look at the dashboard when they wanted to understand every morning how the health of the business transactions are. So I'd say my tip would be get product people involved in the value of observability, and then everything will fall into place, he says, hopefully.
Okay, thank you very much again, Toli. Great talk.
Thank you.
Security is everyone's job, but the current security toolset has not been built with modern engineering team speed in mind. Today, we are going to show you how Datadog makes securing production services as easy as monitoring reliability or performance with Application Security Management, or ASM. From the Application Performance Monitoring Service Catalog, we can identify at a glance services that are at risk. Check out services with vulnerabilities in your open source libraries by filtering on the vulnerabilities column. As an example, this service has 24 critical vulnerabilities. We can find out which libraries need to be updated right now by clicking See Vulnerabilities in ASM. As an example, this log4j library is vulnerable and puts 2 services at risk. The next step here would be to involve the relevant team. Going back to the service catalog, by looking at the signals column, you can respond to meaningful attacks against your services. Here, we notice that user auth doesn't have ASM enabled on it, yet it has high signals. In just one click, we can enable it to know if any of the vulnerabilities we looked at are being exploited by attackers. A few hours later, let's say you get a notification that there is a critical security signal. ASM alerts you in the tools you currently use when your attention is required, such as Slack or PagerDuty. It looks like ASM detected that a SQL injection vulnerability has been exploited. Let's dive in. Immediately, we know which service and environment has been targeted by this exploit, and which team to loop in case you need to investigate further. I can also see more details about the attack path and all the impacted services. The attack flow shows us that the SQL injection attack propagated deeper in your system, reaching a service connected to a database, storing customer data. The most targeted attacks will be performed by authenticated attackers. ASM helps you go beyond the IP to quickly identify the bad actor in your user base. As an example, this user with this ID attempted to exploit a SQL injection vulnerability. The challenge here, though, is that you know there's an attacker in your environment who can cause more harm as you wait for your relevant teams or as you go about fixing the vulnerability. We'll choose to slow down the attacker by blocking this IP for 12 hours as we work to patch the vulnerability in our code. Now that we have stopped the attacker, we have time to investigate further and see what exactly needs to be fixed in the code base so this doesn't get exploited again. We can easily identify the endpoint that was targeted with the SQL injection pattern that then got executed by the database. This proves that the endpoint is indeed vulnerable to SQL injections. This brings us to the end of our demo. You're now one click away to secure your web apps and APIs with Application Security Management. Enable ASM today or start a free trial from our website.
My name is Blaine Schanfelt, and I'm a site reliability engineer at Instacart. Instacart is a same-day grocery delivery service available throughout North America. At Instacart, we've been using Datadog since December of 2018. We've integrated with logs, metrics, APM, and security monitoring. One of our favorite features of Datadog logs are log analytics. Some of our use cases for log analytics are tracking latency within our system to follow our users' actions from the load balancer through to the application. We're able to see everything from database queries to views and the page time, response time, latency, and certain actions within our system. Before we integrated with Datadog logs, it was very difficult for us to rehydrate or search archives of logs. Engineers would download certain log files to their systems, and it was very difficult to do a search and even collaborate on those logs. So now with log rehydration, we're able to reindex and scan those logs, search those logs, and collaborate on those logs for security audits. At Instacart, we really care about unauthorized access through credential stuffing. With Datadog security monitoring, we've been able to track down malicious third parties and protect our users more quickly. All of our teams are able to use Datadog's integrated products, and we're able to share across the security organization, development, and infrastructure analysis, reports, dashboards, and views of our logs, metrics, and monitors. And Datadog's integrated products allow us to make sure that we're following our SLAs and delivering fast service to our customers.
Let's talk about a team shipping a new website. They're launching soon and have spun up a number of new containers to power the back end. This is a footprint of all the containers in their infrastructure. Every container is represented by a hexagon, which is color-coded based on high or low CPU utilization. Gray or red means the containers may require a closer look. But it's difficult to figure out why a container is using more CPU without also factoring in the services that are running on them. Many of these services are often one of the biggest blind spots to monitoring their infrastructure's health, and connecting the two isn't easy. Introducing Universal Service Monitoring. Universal Service Monitoring automatically discovers, maps, and monitors every service running on your infrastructure, all without making code changes and without redeploying. Getting started with Universal Service Monitoring is as simple as flipping on a switch in the Datadog agent. Under the hood, it works by hooking directly into the Linux kernel using a powerful technology called eBPF. This ensures both security and low overhead, even for high throughput microservices. Once enabled, Universal Service Monitoring starts discovering services and populates them and their dependencies in the service map. You'll see both microservices that your team built as well as off-the-shelf or open source software. Every service Universal Service Monitoring discovers is now covered with consistent health metrics, throughput, error count, and latency, meaning you can cover your entire fleet of services with a single monitor. And you can sleep soundly knowing that every new service will be automatically discovered and monitored. This not only eliminates blind spots, but whenever an incident occurs, you have the breadth of coverage and dependency mapping that's needed to identify where the root of the issue is and its scope, all without requiring the involvement of individual service owners, letting them focus their time on product innovations while you focus on quickly rolling out high-quality baseline monitoring everywhere. Universal Service Monitoring also populates the service catalog, the central hub of all service-related knowledge with every service it discovers, enabling you to centralize governance and consolidate knowledge about each service, like the service's real-time performance, owners, contact information, and incident response playbooks, as well as SLOs, alerts, and deployments, all in one place. This makes Universal Service Monitoring and Service Catalog the perfect place to start your rollout of metric or monitor-based service level objectives, such as availability or latency SLOs. And they're all tracked in one place, so you can ensure they're kept within their error budgets. This is what it looks like to adopt consistent observability standards across many services and teams, like what's been done for this team. Furthermore, Universal Service Monitoring helps you keep your systems up and running, even if you're not the owner of a service that has triggered the alert, such as this alert triggering on Vendor Order Service, which is an off-the-shelf piece of software this team deployed to accelerate their time to market. You see on these charts the service's current load, latency, and errors. It appears the error rate and latency are elevated. We'll continue our investigation here, but we could also export any of these metrics to a monitor, dashboard, or declare an incident. Scrolling down, you see the endpoints that were automatically discovered by Universal Service Monitoring. There are elevated latency and errors on the orders endpoint. Let's understand why through Datadog Unified Tagging, which puts service metrics, infrastructure, logs, and more together in a single pane of glass, so you don't have to switch between different monitoring tools and windows. You can quickly rule out any issues with the services caused by the underlying infrastructure, like crash looping pods or an under-provisioned cluster. It looks like everything is running as it should. Checking the recent deployments, there's definitely a spike in errors and latency that were introduced in a recent change. Datadog automatically picked it up thanks to Datadog's built-in version tagging on the services. Let's investigate this further by taking a look at the automatically correlated log patterns. Log patterns analyze your log lines in real time and group them together based on common patterns. We can see there's a new frequently logged item likely related to the errors we're seeing in the new version of the service. Seeing that the change in the recent deployment is the culprit, you can easily reach out to the right contact, whether the on-call rotation or service owner, to remediate the issue. And if a deeper investigation of the cascading impact is needed, Universal Service Monitoring is tightly integrated with the greater Datadog platform, including APM, real user monitoring, and database monitoring, so you can easily drill down into the individual requests with seamless one-click correlation across the full stack. Try for yourself and see how Datadog Universal Service Monitoring gives you the foundation of observability for all your services running on top of your infrastructure today.
What is the problem you're solving with the log management?
We wanted to make sure that developers were able to see in their code in a single place. We could use print statements, we could use other services, but it wasn't something that would scale over time.
Back in the day, when we started, we have a lot of logs flowing to the system. It was hard to understand where is the cost going and what is high volume, what is low volume.
For us, it's very important to have good insight about what is happening in our infrastructure.
And why did you choose Datadog Log Management?
We have a solution where we can ship the logs to Datadog directly, which is very beneficial for us, especially when we are scaling company and sending a lot of logs these days.
We like the pattern feature in Datadog Log Management because we have a consolidated view on our logs and can focus on the important issues.
Being able to tag log messages based on what EKS node they're running on, or what environment they're in, or what service they're in. I think that would be the single biggest convenience that comes from log management with Datadog, is the tags being attached to the log messages and us being able to search off those tags.
My name is Justin Bedoich. I'm a system administrator at Planning Center. We have over 40,000 organizations and millions of users that we help with everything related to running a church. From service planning, scheduling volunteers, kids check-in, giving, small groups, anything that a church does, we aim to help make it easier. We run over 300 servers on AWS at our peak, and we have over 10 billion lines of logs per month. Since we introduced Datadog, everything has become so much simpler. It's so much easier to make alerts, to create them, tweak them, to get the information that we need from our infrastructure. We're able to do things that we weren't even dreaming of with our previous logging provider, where we can create metrics from logs that we're not even indexing, but are getting sent to Datadog, and now we're able to get information from those and create dashboards and get observability where we didn't even have it before. As we moved to start using containers and serverless, one of our concerns was that it was going to be harder to get that information we needed from those tools. But when we started checking out Datadog's container monitoring and serverless monitoring, all of those fears went away. With serverless monitoring, we're able to quickly go in and see even the costs of our functions in real time as they're accruing. We're able to see failures happening and quickly diagnose what's going on with those and create alerts based on what we're seeing with those functions. Without good observability, we go on wild goose chases all the time with hunches about what might be causing a problem and spending hours on a solution that may even make things worse. So having good observability helps us to laser focus on what actually needs to be done.
Hello and welcome to the demo on Datadog CI Visibility. I'm excited to show you how you can gain visibility into your pipelines and tests to help you and your teams better manage your CI and make your DevOps workflows faster and more reliable. Our product has two major categories of functionality: testing visibility and pipeline visibility. let's get started on the testing side of things. Datadog CI Visibility provides robust visibility into managing flaky tests, understanding how your tests are performing end-to-end, and lets developers know if they're about to introduce a regression before they merge. Our default branch view helps engineers proactively identify high-level information about trends or patterns of the default branch. For every branch, you can see the number of flaky tests, a test that both passes and fails despite no changes to the code or test itself. Here, we have the P50 and P95 wall time, which is the real-world elapsed time that your tests take to finish. We also show you the status of the latest commit to the default branch and the Git author information. Let's click into one of the test services for more information. Here, you can see more information about your latest commit, past commits, as well as general insights for the branch. For each commit, we show you the information most useful for the developer who authored the commit, if there are any failed tests and whether they're known to be flaky, if the developer is about to introduce a new flaky test, or if they're about to introduce a performance regression as compared to the default branch. You can also see the flaky tests that we've identified along with information to help you triage. You can see the average duration of the tests, see when they first flaked and last flaked to help you identify which commit introduced or caused the flakiness. Datadog also provides ways to manage your flaky tests. You can manually remove a flaky test if you fixed it. Alternatively, if a test hasn't flaked in the past month, we'll automatically remove it for you. We have a table of your slowest tests to identify some of your slow offenders, and we aggregate all of the common error types being thrown. Let's go ahead and investigate this flaky test. On this Overview tab, you can see the test execution time and more detailed information about the commit and configuration. Pivoting to the Trace tab, you can see the distributed trace of the test, which is quite powerful for integration testing. Underneath the root span, you can see all the spans created by this test request to help you identify dependencies, bottlenecks, and understand what the test is doing. And if you have instrumented your applications through Datadog APM, we leverage that to maintain context to show you the end-to-end trace of what your test was doing throughout the entire request, even across environments. This makes it easy to catch and solve complex test failures with many dependencies, and ensure that developers don't waste time reproducing issues. The Pipelines Overview page is a great starting point to visualize all the pipelines across all your CI providers. It ensures build or platform engineering teams have a single pane of glass into the entire CI system. As you can see here, Datadog surfaces information about the default branch, total executions, failure rates, average build duration, P95 duration, and the latest status. This makes it easy to identify what your most used pipelines are, which of them have the highest failure rates, and which of them are slowest, allowing you to benchmark performance. Let's click into a pipeline to dive deeper into performance metrics. This overview page shows you the pipeline executions and failures over time. It also shows you how much time is spent per stage and how this might be changing. We also have aggregations over all the individual runs shown through a state summary and job summary tables here. This makes it easy for engineers to come into the job summary table, sort by failure rate, and also have a quick rundown of the most problematic jobs causing their pipelines to fail most often. Furthermore, you can also see we have the raw underlying data of individual pipeline executions. Let's click into one here to further analyze. As you can see here, we visualize the pipeline as a trace where the top-level span represents the pipeline itself and the various stages and jobs are grouped below. This makes it easy to understand what a pipeline is doing, what's running in parallel or sequentially, and what stages and jobs are taking the longest to help you easily identify problematic areas. You can unlock the full power of the product by adding custom tags and metrics to your pipelines and jobs. Here, you can see that we've added a custom metric that tracks our code coverage over time and we've also tagged the job with the team name it belongs to. This allows you to set an alert to trigger if the code coverage dips below a certain value and filter dashboards by team name. This is a good place to emphasize that the two products under CI visibility, pipeline visibility and test visibility, work better together, so you can see the number of tests that failed as part of this pipeline execution. You can click into the test and see what tests ran as well as those that failed. In the rightmost column, you can see what test service they belong to in order to get in touch with the team responsible. If you want a high-level overview of your entire CI system, we have an out-of-the-box CI pipeline dashboard that we built for our own build engineering team at Datadog. CI visibility works with some of the most popular solutions, including GitLab, GitHub Actions, Jenkins, Circle CI, and BuildKite. This dashboard contains data from all of the CI providers you set up, and you can filter by CI provider, pipeline name, or branch. It provides a great starting point for investigations. You can see your pipeline, stages, and jobs to see how they're performing. You can also click on anything here and drill down to the exact executions that catch your interest as part of your investigation. Lastly, you can create monitors on top of your CI data. It's easy to create a monitor on top of pipeline or test data. Some of the most common use cases are to create alerts for when pipelines take too long or when there's a pipeline or job failure, and when new flaky tests are introduced. Or by leveraging custom metrics, you can alert on key metric thresholds like code coverage, binary size, Docker image size, etc. To wrap things up, I would like to share that by using CI visibility, Datadog's internal teams were able to shave off 40% of our test suite time, and things that used to take 3 to 4 hours to fix now takes as little as 5 minutes due to all the extra context captured for you in CI visibility.
What is the problem you're solving with synthetic monitoring?
One of the biggest pain points that we had that we needed to look for a synthetic solution was that we're doing a lot of manual tests, especially for like our backend deploys. During our release process, we would be manually testing pretty much everything out twice a day to make sure things go out to prod okay. And it was just wasting a lot of engineer time.
Why did you choose Datadog synthetic monitoring?
Datadog Synthetics has allowed us to move off of manual testing and completely automate our smoke testing process for our backend releases. Additionally, Datadog Synthetics has allowed us to move some of our services to a continuous deployment process. And we're going to continue that with the rest of our services with the help of Datadog Synthetics.
What is the problem you're solving with Datadog's platform?
Yeah, so at the time we had an open source off-the-shelf solution for monitoring, and it just was not getting us all the way there. We had some insights, but not the level of detail that we really needed to solve our problems.
Why did you choose Datadog's platform?
Datadog allowed us to quickly deploy an agent to each one of our hosts in the store and understand real-time metrics and get our logs out of all those machines and be able to correlate them and create new alerts to help stabilize our system. After implementing Datadog, we've been able to reduce our downtime by over half. Not only improve the customer's experience, but the team members' experience.
In modern hybrid cloud environments, teams need visibility into every piece of their physical infrastructure, from servers to network equipment. Traditionally, network engineers who are responsible for on-premise infrastructure use siloed monitoring tools, which prevents teams across an organization from using a single source of truth to troubleshoot. That's why we built Datadog Network Device Monitoring. NDM unifies health and performance data from routers, switches, firewalls, and other network equipment with observability data from the rest of your infrastructure and applications. By automatically discovering all devices from any network, NDM gives you complete visibility into your entire inventory of network hardware. You can quickly pinpoint connectivity issues causing an outage in a specific data center, or drill down to view the performance of a single device and its interfaces. For example, an anomaly detection monitor can notify you if errors suddenly spike on a specific device interface, which may slow down your network. To investigate, you can navigate to an out-of-the-box dashboard already scoped to this specific device and interface. Since inbound errors on this interface have surged, it's possible that an upstream issue is responsible. The network device list helps you confirm if this is the case. Here you can get an inventory-like view of all your network-connected devices and use filters to inspect connections between interfaces. In this example, the interface that's exhibiting errors communicates with a device that is experiencing high bandwidth saturation, interrupting its ability to send data downstream. To prevent this kind of network issue in the future, you can create an outlier monitor in Datadog that will automatically alert you when bandwidth utilization on a specific interface is higher than the others on a given device. You can then make changes to the hardware before customers experience an issue. Datadog NDM provides complete visibility into every device and every interface on any network. And with our single unified platform, all teams across an organization can access the same observability data to quickly determine if the network is responsible for an issue and address it. Start a free trial of Datadog today.
Here, we will show you how synthetic monitoring can help the engineering team at the e-commerce site Shopbus give their customers the best possible user experience. After learning that issues had made their way to production previously, the team wants to make sure that their checkout flow functions as intended through monitoring proactively so that the business and customer experience don't get impacted. To do that, the engineering and SRE team decide to monitor their checkout experience using a synthetic browser test. Let's quickly take a look at how they can set that up in Datadog. Creating a browser test in Datadog couldn't be easier for the team. They can begin by simply providing a start URL, giving the test a name, and selecting which browsers, device types, and locations they want to run their test from. If they don't see a location that they want under our managed locations, they can easily set up their own private location to monitor from another vantage point or monitor any internal-facing applications. They can also set up their desired test frequency, alerting conditions, and permissions below. We integrate with popular communication tools like PagerDuty and Slack for alerting notifications. Once we have the basics taken care of, we can hit Save and Edit Recording. After installing our browser add-on, they can click Start Recording. With the codeless web recorder, we automatically track all interactions across their web application with the ability to add assertions at each step. Datadog's multi-locator algorithm ensures that their tests are self-healing and that they wouldn't be alerted to false positives such as styling or placement changes for their web components. Once the test is scheduled to run, the team can check out the test details page to see all their test runs. Customers can view sample runs to inspect test failures in more detail. They can see information for site performance metrics such as largest contentful paint and content layout shift within the sample test run, and see which steps are displaying page front-end errors. Because the team has instrumented their services and application with Datadog APM, they can click into a trace to pivot over to take a closer look at the relevant metrics, traces, and logs to identify where issues are coming from. If we take a look at this particular trace and quickly follow the error breadcrumbs, we can see that the payment service is reporting a 503. The engineering team can now focus on fixing the payment service availability. Coupling APM with synthetic monitoring is a great way to expedite troubleshooting.
Hello, welcome to our third breakout session. This is a live stream, so welcome to for those of you who are watching on the live stream. And for Q&A, to make sure that that people in the live stream can participate, what we are going to do, if you want to ask any questions, please scan that QR code now, because it will disappear at some point. We will show it again at the end of the talk. But basically, type the question, and then I'll relay the question afterwards. So our next speakers are my colleagues in Datadog, Tay and Mitch. So Tay has been part of several reliability-related teams at Datadog, including the chaos engineering and the caching platform. And today, she's a technical program manager for high-performance transaction system. And also, she's a Google Slides wizard. So please check out her LinkedIn profile, because you can see all the art that she's able to make in Google Slides. It's pretty amazing. Mitch is a senior engineering manager for the application data services, a team which is responsible for providing data platforms ready to use by all the product engineering teams at Datadog. And he was actually a founder of the caching platform at Datadog, so he will be able to share a lot of things. Mitch also loves sailing. He's trying to get back to sailing, but he's in New York now, so he's finding that a little bit more difficult to do it on the Hudson River. He's originally from Australia. That was a lot easier back then. And together they're here today to share how caching evolved at Datadog over the last decade, and how platform engineering simplified things for our application teams to improve reliability of our systems. So please, a big round of applause to Tay and Mitch.
Thank you, Anna.
All right. So we just got introduced, so I'll skip this slide. Now, you might have heard this quote before. There are only two hard things in computer science: cache invalidation and naming things. There's also another one where there's an off by one error in there somewhere. And I was coming out of the subway last Monday, going to the Central Park Zoo, and there was a guy coming out going, off by one error, no! And that's just how this industry is, right? So what could be more frustrating than off by one errors? That's what we're here to talk about. Let's start with a definition. A cache is a component that stores data so future requests for the same data can be served faster. Now, a component could be hardware or software, and the data could be something that is a result of an earlier computation or just a copy of something stored somewhere else. Many of us have cleared a browser cache before in an attempt to get something to work. So in this case, every time you load a web page, you need some data from the internet, and then your browser actually stores some of that information, so next time you come, it comes faster. And that's an example of a software cache. There's also hardware caches. So an example is in your CPU. There's multiple tiers of caches in your computer. Some of them are really expensive and go really fast, and others are less expensive, but you can buy a lot more of it. So all of these layers do return data faster than from live memory or your hard drive. If you take a step back, there is a global cache, a content delivery network, and this helps us get our ebooks, audiobooks, cat videos to come faster to us by saving a copy locally in proxy servers. But none of these are the cache we're talking about today. So what are we talking about today? So there's a thing called distributed caching, and here's why we need it. Typically, when you have an application, you have some user devices, and they're reaching out to an application server, a fleet of servers that respond to customer requests. And then some amount of those requests require us to maybe access a database or some sort of other backend service, which maybe does computations faster. Now, sometimes the database or backend service is too slow for your use case. Maybe your users are getting frustrated, waiting for something to load. You want it to go a little faster. And in this case, you can set up either an in-memory cache or a remote cache. So an in-memory cache, as its name explains, is something that you can put right in the memory of your application service. So they're coupled in the same machine. The remote cache, on the other hand, is an actual extra component, so there is an extra network hop there. But there's many reasons why this could be beneficial. The first is it decouples the lifecycle of the cache from the application. So say you had 5 instances of your application server and they're all responding to requests. Then when one of them is restarted, maybe you're in Kubernetes, so it's a pod. When the pod's restarted, the cache empties. Empties might not be the right word. The new cache is empty. And so suddenly 1/5 of your traffic is now hitting the back end, which may be something that your application will slow down because of. With a remote cache, you have control over when you reset that cache because it's not attached to the life cycle of your pod. The other example of how this is advantageous is that when you have like A, B, C, D, and E application servers, only one of them needs to get the data cached for all of the rest to benefit. And that might not seem like a big deal, but if you have 500 application servers, then at scale it becomes really convenient. But with all great things, there's also risks. So one of the risks that's pretty common with caching is stale data. You have to be really careful about what it is you're caching. Maybe you've experienced this when you're trying to get concert tickets and you're like, oh, should I pick the 2 in the front row, but maybe I'll be craning my neck, or should I pick the 2 in the back? And by the time you and your date have decided and go to buy the ticket, it's already gone, and maybe even the ones in the back row are gone. So if someone's coming out of the subway going, "Arg, cache invalidation," maybe this is what they're talking about. Another major risk of caching, specifically distributed remote caching, is, let's go back to that diagram that I was showing you earlier. You could have a load-bearing cache without realizing it. And what that means is, for example, maybe your application is happily serving 1,000 requests per second, and that's hitting the back end, and your back end is successfully responding. But then you put a remote cache there to make it go faster. Something about this UI being snappy, maybe your PM asked, hey, can you make this application go faster? So you do it for speed. But because these requests are responding so much more quickly, the application server is suddenly able to handle a lot more requests. So your snappy UI is very popular. So you start serving 10,000 requests. But if you never load tested the back end, then now you could be in a bind. Because what happens when your cache goes down? Now, 10,000 requests per second are hitting the back end, but it could only handle 1,000. And one of the dangers there is that even after you put the cache back, if your back end is down, it can't actually get the data to repopulate. So in most cases, in engineering, if you bring that correct setup back, then everything works out. But the danger of a load-bearing cache where the cache goes down is that because it's toppled, you can't repopulate the cache, and so this issue can go on for hours and hours. That's what we mean by load-bearing. So now that we have some concepts down and you're all caching experts, let's look at how this relates to Datadog. So the history behind the caching platform that we ended up building here is that for 10 years, we didn't have one. And in just the last 2 years, we brought up a dedicated caching team. And so I'm going to take you through that process, and then after that, Mitch is going to tell you how we built what we built. Okay. So originally, Datadog was only in one cloud provider in one AWS region. And so when we needed caching, because of the use cases I described earlier, we had an Elastic Cache in Amazon, so it was Redis, and we just served data to all the applications through it, and there weren't that many applications. We loved this. It was quick to get started. We also implemented like a pluggable cache interface that actually aged really well. We still use today. So all the teammates could just like plug into that and get the data that they needed. A problem that we started seeing as we grew is that because they were all in one Elastic cache, if someone were to bombard the cache or whatnot, and the cache started to not perform very well, it impacted everyone. And another con, which I'll get into more detail in a second, is that we started to onboard other cloud providers. As you all know today, we offer more than just AWS. So then maintaining those subtle differences across cloud providers became more and more difficult. So let's dive into that. Amazon Elastic Cache is an offering of AWS. It does not exist in Azure and Google Cloud. And so in a hybrid cloud ecosystem like the one that we're in, there is a high cost to leveraging cloud provider managed services, because in one cloud provider, X is the default setting, in another, it's not even an available setting. And you really have to think through what's available in each cloud provider, and each team was doing this, right? Each team has to think about this on their own. And so around that same time, we started adopting Kubernetes and scaling really fast. And so we thought, okay, why not make it so every team can use Helm charts and just deploy Redis the same way in every cloud provider, not using the cloud managed services. And we like this. One application could have just the one Redis pod, but then other applications that needed a little more durability might choose to have replica to cut over to, and in that way, make sure that uptime is much better. And then some teams, they were growing so much that they needed to partition their data across a Redis cluster. And all of them could do this using the Helm charts, whatever they wanted. And we loved that flexibility, and we were really loving the cloud agnostic nature. However, as we grew, we definitely started seeing fragmentation. There was not a knowledge silo, so just because you were a pretty good expert at managing Redis in one team didn't mean that that knowledge carried over. Best practices were lost from team to team because everyone was doing their own thing. And every application team managed their own special infrastructure, which had overhead over time. And so now I'm going to pass it over to Mitch, and he's going to talk about how we reduce that entropy and improve Datadog's reliability.
Thanks a lot, Tay. So what we did is we just looked at the caching footprint across Datadog, and what we really saw was that caching became a burden for every engineering team. On the right here, there's a Datadog container map, and this is illustrative, but is really representative of what our caching footprint looked like. We had a few very large caches with many, many pods, and then we had a long tail of smaller caches. And part of the problem is all these caches were owned by different teams who each had to understand everything they needed to operate Redis reliably. And as I was looking at this, sort of stepping back, you know, I genuinely didn't know there was this much Redis in the whole galaxy. So while I was thinking about this, our team reflected, and we knew that Redis is great, it's easy to use, it's performant, it's efficient, and it's the most popular caching software in the industry. However, internally, what we began to see were a degree of ops overheads. So we had a lot of security requirements, we had to do end-of-life version upgrades, and generally teams had to scale their caches for performance and efficiency. Secondly, we just saw growing complexity, so it was a burden to understand all the Helm charts, and it got quite hard to deploy a cache when there were so many options available. And finally, there were reliability risks. So we had some scaling and isolations errors in the past that Tay touched on, and that did cause some severe outages that sometimes cascaded into these thundering herds. So based on what we were seeing, we decided that we were going to introduce Ephemera. What Ephemera is a managed caching service for accessing Redis internally at Datadog. We've been building it as part of the internal caching as a service team, and as the team was designing Ephemera, we really prioritized it to be, first of all, simple, so both in terms of our API and architecture. Secondly, reliable, so we have SLOs and on-call rotation and so forth. Third is scalable, so Ephemera both horizontally and vertically auto-scales based on load. And finally, isolated, so that's just to avoid the noisy neighbor issues we had seen with caching in the past. The third part here, being a managed service, we really cared about a great user experience and how our users interfaced with Ephemera. So this comes to self-service workflows, great clients and documentations, dashboards. I'll touch on more of that in the talk. And finally, we're really building an opinionated cache. So Ephemera isn't necessarily just managed Redis. Instead, what we're trying to do is focus on the caching use case and doing that as best as we can. I want to say, humbly, I think Ephemera is mostly boring, actually. We're not reinventing the wheel here. We're not designing it from scratch. We still do Redis, and we have plenty of workloads that we had to migrate over to Ephemera. So it is kind of boring, but I also think it's an interesting journey in terms of how we went from teams operating themselves to the managed platform. What I'm going to spend the majority of the talking, well, Tay and I will spend on, is a bit of the design process we went through creating Ephemera and its architecture. So where did we start? Well, we actually started with a post-mortem analysis. So Datadog has a great SRE-style blameless post-mortem culture, and as we got started, a small team of us reviewed 5 years of caching-related post-mortems. On these post-mortems, we sort of collected patterns of their root causes, some of the factors that contributed to the outage, and also the action items that the team members took to try and prevent those outages in the future. And those action items were really informative to us in terms of the features that we wanted to build in Ephemera. And so what were some of those features? I'm going to quickly break down 9 features and sort of put them into categories that we prioritize building Ephemera. And the first category, I'm calling caching table stakes here, are really the essentials. And of course, a cache needs to be performant. So on the right here, we see the client-side latency histogram for calls to Ephemera. And what we're seeing here is that the P50, the median latency, is 1.1 milliseconds, and the P99 latency is 8 milliseconds. So Ephemera is generally pretty fast. And actually, the SLOs we offer our users are 2 milliseconds and 15 milliseconds respectively. So we're sort of twice as fast as what we're promising. And we're doing all this while serving tens of millions of requests per second. So generally proud of the performance there. Secondly, of course, it needed to be reliable. So when I say reliable here, primarily I'm talking about the availability and latency SLOs. On the right there is a screenshot of the SLO app in Datadog. And we actually have a bunch of SLOs configured for Ephemera, but this is our main server-side aggregated availability SLO. And we see here that our target is 3 nines, but looking over the past 7 days, I took the screenshot last week, we've actually been doing 99.995. So that's 4.5 nines, and you can see that error budget burn down is basically at 100%. So this is generally, I would say, reliable, and also we're focusing there on the availability and the latency. Durability, as a matter of fact, is less important for us. It is a cache after all, and we're okay if we lose some data here and there. I think the worst thing would be, I'm happy for the cache to drop data compared to stalling and then potentially having our application sort of grind to a halt waiting for the cache. The third table stake is just having a simple API. And here, simple API means easy to use. So as Tay touched on, we did have that cache interface almost a decade ago now, so we were just able to implement Ephemera using the same simple interface. And we found that this is sufficient for the majority of the use cases we have at Datadog. There wasn't a need for implementing fancy Redis commands or Lua scripts. We're really just doing simple caching here. The second set of features is what I'm calling sort of the managed service that is Ephemera. And here, the first part that's the most important is the data ownership. So Ephemera caches a single tenant. And with that, we can limit the blast radius if something goes wrong. And in each cache, we have some metadata associated with it. On the right here, I have a screenshot of the service catalog. And this is, again, just illustrative, but we genuinely use this internally, where you can list all the Ephemera caches. And for each cache, you see the team that owns the data. You can see the person that's on call, the Slack channel to reach out to that team. And where this information is useful is, if there is an incident, then we can reduce the resolution times and know who to escalate to. The final part of data ownership is that we have authenticated access to each cache. So we limit access to the intended users only. And that has a lot of benefits, like obviously it improves internal security, but also in case someone unintentionally connects to a cache they didn't mean to, or if we have some service discovery bugs, it just makes sure that every connection is enforced as we expect. Second part here is self-service. So this comes back to how we think about users interact with Ephemera. And an objective here, as an example, is that an engineering team in Europe should be able to modify their Ephemera cache while the caching team that's primarily in New York is blissfully asleep. So to do that, we've created some self-service workflows. And we have workflows to deploy a new cluster, to delete a cluster, to change authentication, and so forth. We use Temporal to build those workflows, and users interact with it via a CLI, GitHub, and Slack. So in this example on the right here, what I've done is I've created a new cache for this talk, and then the Temporal worker wakes up, it generates a PR to instantiate the Helm chart, and then sends it to me for review. After I review that PR, the worker will then merge it, trigger the CI/CD job to deploy the cache, and then after a few minutes, when everything's ready and available, it'll send me a DM on Slack saying it's ready to be used. The final part of being a managed service is how we think about the scale of ephemera. And we as a caching team can't hand-tune hundreds of deployments, right? So instead, ephemera has horizontal and vertical auto-scaling. For the horizontal scaling, we use Datadog's open source watermark pod autoscaler, and then we also bin pack our ephemera pods on large shared nodes. And where that's helpful for us is it pushes our efficiency up, and if a team wants to deploy a new small cache, the marginal cost of that to fit in the gaps is basically nothing. On the right there, I chose a particularly chatty cache, I guess, which over a week has scaled between 7 and 14 replicas to react to the load. Moving on, sort of when we think about ephemera as an opinionated offering, the first part is that it's non-durable. So this sort of comes from the name ephemera, right? Like lasting for a very short time. When we say non-durable, we just make no guarantees that any individual key will last around in the cache. Like obviously we do our best, ephemera wouldn't be useful if it just forgot everything, and we definitely avoid losing large chunks of the cache's data, but we just don't want ephemera to be a source of truth, where it's not a long-term database, it's a cache. And one of the key ways we enforce that is that we require short TTLs on any key that you write to ephemera. Second part here is load shedding, so how we think about the load that gets this cache. And to be honest, some of our cache workloads can sometimes be surprising. It's not uncommon for us to see 100x load spikes or micro spikes where all the load is focused over a few milliseconds. And basically trying to provision for that peak load while keeping ephemera efficient is practically impossible. So instead, we take the strategy of load shedding. And in the example on the right here, we see a cache that was serving maybe 1.8 million requests per second, and then it suddenly spiked to 4 million requests per second. And so this did trigger load shedding events, but what we see on the client-side latency in the next graph is it's small, but the P50 and P90 latency is basically flat. And yes, due to some of those retries because of the load shedding, the P99 did spike, but generally I'd say we're proud that ephemera handled this spike without any incident. And finally, the isolation of ephemera. So I touched on this in the data ownership part, but when we think about isolation, it's not just each cache being its own deployment, it's also how we think about the entire ephemera system. So we have a gradual automated rollout when we upgrade ephemera, and I've illustrated that deployment plan on the right here, where we go through region by region, and for each region we start by deploying our canary caches, which are internal caches we use for functional testing. And then after 15 minutes of synthetic tests, if everything looks good, then we deploy the standard set of caches, where this is the majority of our users. And again, we have monitors and we have automatic sort of freeze and rollbacks if things regress. But if everything looks good, then finally we deploy our critical caches. And these are those load-bearing caches, which if they were to go down, it's a severe outage. The other part I'd say for isolation is that we care a lot about how users test and develop with ephemera. So there we have developer environments using Tilt, where it's quick to get started with ephemera. And we also have some runtime experiment options, so you can do some A/B testing in terms of how your cache works. In terms of the scale of ephemera, moving beyond the features, these are some of the numbers we're proud of, I guess. We're serving tens of millions of keys per second. We have hundreds of deployments of ephemera, which are serving dozens of engineering teams. And on that last point, while I was putting this slide together, I saw this template of all of Datadog's products. I think this might actually be out of date now based on the keynote, but when we were looking at this, Tay and I were exploring which of these products are powered by ephemera. And we're quite proud to see that almost the entire company is onboarded. And for teams that aren't directly using ephemera, they still use it indirectly through some of their platform dependencies. And here, I think that ephemera has helped Datadog in terms of how we move quickly to build new products. It's just a small part, but having teams no longer have to worry about this one data store and instead focus on their product, I think has been pretty neat. Moving on, I want to hand it back to Tay to talk about our system architecture.
Awesome. So now that we know what ephemera offers, let's take a peek underneath the hood to see how it's done. So this is what we call an ephemera installation. It's a fully managed cache deployment. And we designed it, as Mitch said, to be simple, stateless, and fault tolerant. So let's get started from the right side, which is where our actual Redis pods are. So this can auto-scale on memory, and by default, we'll give you 2. That's so if we lose one, we're fine. And what's really cool here is there's no shared state between the pods, but you can scale, I've seen, as much as 100 Redis pods, and there's only one copy of the data across all of the pods. And that's nice because you can bring down Redis pods and bring them up, and the Redis pods are stateless. But how do they know which Redis pods have what data without coordinating between each other? That's where the API server comes in. So that's what really decides. It maintains a connection with all of the Redis pods and decides where a subset of the requests go, if it's like a get many, for example. So at Datadog, we use gRPC predominantly for microservices. So it's a gRPC service. And again, we'll give you 2. And this one, we, after having a few beta testers, realized the bottleneck is CPU. So we auto-scale on CPU. It's actually inspired the way we communicate with Redis by Envoy's Redis filter. And so we'll take a look at that now. So how does the API server know where to store the keys? We take advantage of the maglev algorithm, which was actually developed by Google to power their network load balancers. And what it does is it has a O1 consistent hashing algo that decides which Redis pod the data goes to. And I mean, that's great because we're sharding the key space in a balanced way, but that's not all. That's pretty easy to do, right? Just like pick a random pod. But the goal here is to have minimal key moves when we're scaling. Because as I mentioned earlier, one of the risks with caching and then having pods come down is that you can suddenly have a huge spike of traffic to your backend. So we want to move the keys around as little as possible, because when you move a key from Redis 0 to Redis 1, realistically, it's a cache miss the first time it's hit. And so this algorithm is very clever about stabilizing the movements when you have a different number of Redis pods. And so when you restart a pod, all the keys go back to the one pod that was restarted. And again, it does all this with no control plane state, which makes it super reliable. So this was great. One challenge we did see with Redis when we actually rolled this out is that while systems aren't always explicitly telling us that they're load-bearing, it's in real life, like high performance caches, like if they're tuned well, tend to be on the cusp of being load-bearing. And you don't always know when you've crossed the line. And so when we first introduced ephemera, some teams would feel a lot of pain when we needed to update, say, the Redis version that they were on, so we bring down the pod and bring it back again. And while ephemera is not made to be durable, it was still important that the customers could get updates without forcing an incident if they were already in a load-bearing state. So we decided to add a component that allows you to have a cache that's warmed on the side while your Redis pod comes back up, so that you don't have that spike in traffic issues. And these little tweaks really drove adoption. We don't talk about adoption in this talk, but once you make a service, you need people to want to use it, and these little things helped our users move to us. Finally, how do you actually talk to the cache? So we offer a thin client. We call it the ephemera client, and it does a couple things. First of all, it's a gRPC client because that's what we use here, and that takes care of authentication, actually finding the API servers, and also observability. We hook in your hit rates and how much requests you're making to the API server, and just put that on ephemera dashboard for you. And yeah, the thin client implements that cache interface we've been chatting about. So taking a step back, this is the end-to-end architecture. It is, I think, indeed simple, stateless, and fault tolerant. And what's cool is, aside from like performance optimizations or like swapping technologies here and there, it's basically remained the same for 2 years. And that's because we really looked at those postmortems and understood what our users needed. At the same time, we still evolved it to consistently meet what our customers needed today. And so in that way, I would say Ephemera is still a growing product. So where are we going, Mitch?
Thanks. Thanks, Tay. Yeah, so to wrap up, I just wanted to touch on where we're going with Ephemera in the future. And I do feel that we've solved a lot of the core problems that we're trying to address in terms of the cognitive overhead and scale issues with caching at Datadog, but I still think there's new things we can do here. So 3 things I wanted to mention. The first one is chaos engineering. So 2 factors is making us want to do more here. First one being that, as I mentioned, we really don't want Ephemera to be a system of record. It is just a cache. And secondly, that we are far exceeding our SLOs that we're promising to users. So Datadog has quite robust chaos engineering internally, and we're thinking that by doing some careful disruptions of Ephemera, we can keep our users' expectations aligned with what we're actually offering in Ephemera. The second one, smarter clients. So in the architecture, Tay showed that thin gRPC client, but we do think that if we were to move some more of the logic out of the API server and towards the client, for our largest caching use cases, we would actually see some cost savings and some latency reductions. And finally, multi-level caching. So going back to some of the first diagrams Tay showed of the different types of caching, we could have the local cache, we can have the distributed cache, and then there's the data store. So for the highest throughput use cases, we do think that if you have actually all 3, then it's giving you the best ability to scale efficiently. So here we're trying to take the Ephemera interface and give us some more options to connect all the way through to your data store and have caching work end to end to help you scale. Wrapping up this talk, there were 2 takeaways I wanted to mention. I think the first one has really just been the simplicity of caching throughout Datadog's journey. So we did start with a single Elasticache instance, and that was great. That worked really well and gave us a lot of scale. And we've only iterated and added complexity when it was needed for us. The second one here is when I'm thinking about database as a service teams. So Datadog did need this caching team. We did need to build a caching service. But to be honest, for us, it was after that 10 years of growth. And so it's been interesting for me to reflect on sort of like at what stage does it make sense to have these dedicated database as a service platform teams. And if anyone has other experience here or thoughts about when's the right time, I'd love to chat with it afterwards. But with that, I think that's the end of our talk. So thank you all very much.
Thank you. Thanks both for the amazing talk. We have a couple of questions on the Slido, so I'm going to read this first. Then we open up to the room for any questions. If you prefer to type, you can use that QR code. So the first question is a little bit related to what Tay was saying, that you were not mentioning adoption, so someone is interested on adoption. It's like, how was your experience persuading teams to adopt Ephemera, and what was your communication mode with the teams?
Sure. So because there was pain when we first introduced Ephemera, like there was a reason we brought up this team. And I think that's really important. Like when you're bringing up a new and shiny platform, there needs to be a need for it. So a lot of customers were already interested by the time we were building, and they contributed to the RFC to make it more their vision. So having that kind of early relationship was really helpful to us. But over time, you get to the point where all the people who want to onboard have already onboarded, and you say, where do we go from here? And that's where like actually sitting down and talking to the customers who are like, you know, I don't really want to change my architecture right now. It's a risk on its own. Being able to come up with like maybe dashboards or other reports to explain why you think it's safe and reassuring the customer was really helpful. But at the same time, just respond, like we built a reputation of responding when something goes wrong. And I think that's what really carried the brand of Ephemera to the company.
Fantastic. The other question is, and I know you haven't been in a Datadog for that many years, but you've read a lot about the caching history. So in your opinion, what's the biggest success and the biggest failure those 10 years of cache history at Datadog?
That's an interesting question. I think again, like all the decisions made at the time, I think were the right calls in terms of the scale of the company, in terms of the caching needs. So I wouldn't say it's been failures, it's just been growing pains as we've needed to sort of scale to the next level, be that in terms of the number of products or the specific throughput of one product. So certainly there, I think the multi-tenancy of using one like cluster of a cache which has many different disparate workloads, the failure domains there were all wrong, and that caused some major outages. So breaking up that was, I think, one of the best decisions that was made, and that predates both Tay and I's work in the area.
Good. So the next question that we have, what are the eviction policy options for ephemera? And whether it's going to be open sourced?
Yeah, we'd love to explore that. And so we are using Redis under the hood. So we default to LRU, which is just generally more efficient. And to be honest, most caches see key rotation through expiry, not eviction. So we have TTLs, and by default it's 1 hour, but many users are much shorter than an hour. So we see keys expiring instead of evicting. But some caches are memory bound where we've disabled the autoscaler intentionally, and there it's LRU.
Okay. So next question, we are getting a lot of questions on Slido. So if you have a question in the room, just raise your hand. If not, I'll continue. Okay.
Thanks, guys. Great talk. So you mentioned that it handles horizontal scaling up and down. I was just curious about the algorithm that you use to handle the sharding. How does it do the redistribution? Or is that something that the algorithm just handles for you, or was that something you had to actually handle manually under the hood?
So we looked at we basically looked it up, right? Like the actual algorithm itself for consistent hashing. And I don't think we had to adapt it very much. We did write a lot of tests for it. But yeah, I did review your PR where we did that.
I would add that, especially for the larger caches, like if we're going from 20 pods to 21 pods, then that means 1/20th of the key space is redistributed, and the impacts of that are pretty small. So we've seen in practice that just scaling up and having that small hit in cache misses, applications can absorb that spike. So, and this comes back to us trying to really be a cache and not promising that any keys are going to stick around. So basically it was easier for us just to not solve the problem of how do we handle actually moving the key data. And that's in comparison to something like Redis cluster that will shuffle the keys around, but the more stateless approach for us, I think, allows us to react faster. And what I would say there is, to Tay's point of the update helper, on a planned restart, we still keep the keys. We don't want to drop everything, but for scale-ups, we accept a small loss.
I'm going to read one more question, and then I'll go to you. So I got a question here. Other than TTL, any other criteria for invalidation for critical cache tier?
The critical cache tier is primarily just sort of product driven. So it's products where are more sensitive to cache misses, and the downstream services are more sensitive to load spikes. So that's primarily how we've decided that. And all our caches are critical, but some are more critical.
Yeah, and we sort of leave invalidation to the user by deleting the key. Like they can choose to algorithmically delete keys that are no longer usable to keep their own applications up to date.
So I think you alluded a little bit to it with the smart client. How much of the actual standardization around the client do you attribute to the success of the solution versus what you had before, where maybe developers kind of chose and picked whatever libraries and clients they wanted to use in order to talk to Redis? Because you're still kind of, with the back end of Redis, as you mentioned, you have sort of like this thin client that talks to really a shim to then have this standardized sort of like caching relationship.
Yeah, I guess we can't really know what the world would have looked like without that caching interface already there. It made our job a lot easier to get people to just say, hey, instead of making a call to this thing, make the same call to this other thing. I would say that we've considered like increasing the amount of interface calls that we offer, but a lot of times we just ended up not doing so, and it didn't really impact customers. There's a lot of nice to haves in the Redis library that we could have exposed, but after a lot of discussion, we would often find that it's not really necessary.
And I also just found gRPC to be a great sort of standard interface that we understand well at Datadog. And like in Redis client libraries, there's many different options and a lot of different performance trade-offs. Like for example, in our Go API server, we used to use ReadyGo, and we recently migrated to another library called Roidus, and that gave us some like massive improvements in terms of how it does pipelining. So I think having that API server where we could experiment and iterate has been a really good decision for the team. But now, if we can move some of that logic and abstract it in our clients, we think we have a stable enough offering that that makes sense. But I think gRPC is already standard enough that when we have apps that are in Go, Python, Java, Rust, they can all speak gRPC, and that's made our life easier.
Cool. We don't have time for more questions, but I'm sure Mitch and Tay will be happy to talk to you afterwards. So thanks again for the great talk.
Thank you all. Thanks for the questions.
Super fun.
The pace and complexity of modern environments make it challenging to detect and respond to security threats. DevOps teams understand their own services well, but may not have the time or expertise to secure them. Security teams bring this expertise, but their traditional tools can't always keep up in the cloud and lack the context needed to quickly remediate threats. Datadog's cloud security platform derives real-time security insights from detailed observability data, logs, metrics, traces, and more, so teams can collaborate to secure their production environment. By leveraging the same integrations and lightweight agent that your DevOps teams already use, the cloud security platform analyzes your events for attacks, monitors suspicious file and process activity, and scans your cloud resources for misconfigurations. Using built-in and custom rules, Datadog creates a security signal for each misconfiguration, attack, or threat intelligence match. The platform correlates the most important signals together so teams can quickly reconstruct an attack chain. Datadog Cloud SIEM surfaces threats in real time from your stream of operational and security logs. For example, Datadog will detect if a host starts enumerating your storage buckets. This could be a sign that an attacker within your environment is searching for valuable data. The security signal includes context on the attacker's location and targets. Datadog Cloud Workload Security monitors hosts and containers at the kernel level and flags suspicious file changes and process executions. In this case, a signal from Cloud Workload Security makes it clear that the attacker used a web shell to control the host. You can even see the specific curl command that the attacker executed. Datadog Cloud Security Posture Management continuously audits your cloud workloads and resources for misconfigurations which could weaken your environment. By pivoting to a signal from CSPM, you can see that a misconfigured security group allowed the attacker to reach the host from the public internet. Reconfiguring the security group may be a first step to remediation. Datadog also tracks your conformance with industry benchmarks like CIS, PCI DSS, and SOC 2. Giving you a window into your compliance posture and cutting down time spent on audits. The cloud security platform is closely integrated with the rest of Datadog, so you can seamlessly investigate a security signal with detailed observability data such as related logs and traces. You can also use Datadog Incident Management to declare a security incident and loop in the right team members for remediation. With Datadog's cloud security platform, DevOps and security teams can detect threats across your full stream of observability data and deliver applications together without compromising on velocity or security. Start a free trial of Datadog today.
Fundbox is an AI-powered financial services company that gives funding to small to medium businesses in the US. We have more than 300,000 businesses in the US that already received more than $2.5 billion in business credit from Fundbox, and the numbers are rapidly growing. At Fundbox, DevOps is more than a team, it's a mindset. The idea is that all engineering teams will get notified when there's a production incident, be able to analyze it, fix it, and making sure the fix was successful. Datadog helped us achieve all of those things in one place.
Before Datadog, we had 8 different monitoring systems, each focused on a different aspect of our stack. Working with so many systems made it very hard to track connections and to find root cause when we had issues. Besides the time wasted on investigation of issues, my team also had to invest a lot of time maintaining all of the systems, taking time away from creating new features. Datadog provided us a one-stop shop for everything we needed. They gave us a single holistic platform for engineers to view and cross-reference all of our monitoring data, whether it comes from our network, server, application, logs, or elsewhere. This makes it really easy to pin down the source of the problems. When we have a major issue, for example, when our login page isn't loading for our customers, we have to act fast. Our engineers all jump quickly into Datadog to look at different dashboards based on the flow of the data. Datadog's ability to correlate all of the information allows us to see what is causing the issue.
Datadog helps us in reducing our response time for production incidents. One of the areas is when the engineers are looking to retrieve logs from the past. This is a very straightforward operation in Datadog, allowing us to spend more time in building new valuable features.
Datadog's easy-to-use platform has led to high adoption across our engineering teams. Like one of our engineers said, Datadog is the friend I never knew I was missing.
Why did you need a solution for database monitoring?
Prior to using the database deep monitoring solution, we were using our own custom tooling to extract metrics out of the database. This lacked context. They had to jump back and forth between multiple consoles to figure out issues during incidents.
Why did you choose Datadog database monitoring?
The teams were able to self-serve and look at what their queries were doing. This enabled us to reduce our peak CPU load down to below 60%, which was previously at over 70% during our peak hours. While our orders grew 25% year over year, this offloaded a lot of time and cost that the storage team had to spend prior to this tooling available.
What is the problem you're solving with synthetic monitoring?
When I first joined Whatnot, we did have another vendor that we were using, and unfortunately, it wasn't meeting the needs that we needed. We needed a solution that was much faster to go to market with.
Why did you choose Datadog synthetic monitoring?
The synthetics allowed us to move from having someone having to do all the smoke tests manually through a Google worksheet to just, hey, we have these synthetics set up, it does the exact same testing, and now we just allow it to run after our release goes out and tells us if it's good or bad. So our release window changed from being like an hour-long release window to 15 minutes at tops.
In order to maintain the health and performance of distributed applications, you need to monitor communication between all of your application dependencies. Traditional tools that monitor network performance rely on IP connection data, which can lead to blind spots in ephemeral cloud and hybrid environments. That's why we built Datadog Network Performance Monitoring. NPM visualizes your entire network topology in real time across cloud environments, on-premise data centers, and operating systems. For deep insight into application health, you can analyze the efficiency of traffic between any two meaningful endpoints, from services to pods to availability zones. Datadog maps all of your network dependencies.
Hello, welcome to the last session of the day. So we are going to get questions from the live stream as well. So what we are going to do is, if you want to ask questions in this room, scan that QR code and type the question, and then I'll ask them. If not, if you prefer to talk, I'll open it to the mic as well. So our last speaker for today is Victor Chen. He's a senior software engineer at Airbnb. He was there since 2016, but in the past 3 years, he's in the data frameworks, which is one of the important teams that enable other teams. So in this case, they build platforms and tools around data processing. So he comes here today to share Airbnb's experience with building data stores that are optimized for reading. And fun fact, is not the first Victor Chen from Airbnb who spoke at Dash. So in Dash in 2019, a good friend of Victor, also named Victor Chen from Airbnb, was also a speaker at Dash. So big round of applause to Victor Chen.
Thank you. All right. Oh, cool. It's working. Thank you for the introduction. And yeah, thank you all for coming to the talk today. I know it's the last one today, so appreciate you all sticking around for this. Before we get started, yeah, I just wanted to thank the organizers, the event staff for putting on this awesome event. I've had a ton of fun just meeting people and listening to presentations. And yeah, hopefully this one's interesting to people as well. Cool. So let's jump in. Yeah, for today's presentation, I'll be telling you about read-optimized stores, which is a pretty critical piece of infrastructure at Airbnb that powers many of our data serving systems. Again, a little bit about me. Thank you for the introduction already, but yeah, I'm a software engineer at Airbnb, working on the data frameworks team. We build tools and platforms to help improve the productivity of other teams, specifically around data processing at Airbnb. Yeah, so before I get started, I want to ask a question. How many people have used Airbnb before? Cool. Yeah, that's a lot. That's awesome. So I'm not sure how many of you knew this, but Airbnb was actually founded in San Francisco about 15 years ago in 2008. The story was that there was a design conference in town, but not enough places to stay. And our founders, Joe, Nate, and Brian, hosted the original Airbnb guests on air mattresses in their living room in their San Francisco apartment. And then in the morning, they made them breakfast. And as a result, Air Bed and Breakfast was born. So since then, Airbnb's come a really long way. In 2016, we launched Experiences to try to expand on Airbnb's vision to provide the magical end-to-end trip, not only providing unique places to stay, but also providing guests unique things to do, designed and led by local hosts. Skipping ahead a bunch of years, at the end of last year, we hit some pretty big milestones. So at the end of 2022, we hit 1.4 billion Airbnb guest arrivals for all time. Guests had the choice to choose between 6.6 million listings across 220 countries and regions around the world. And these were hosted by over 4 million members of our incredible host community. So yeah, it's been pretty awesome to see Airbnb scale over the years and just grow. But Airbnb has also run into a huge number of scaling challenges during this time. For today's talk, I want to focus on one specific piece of infrastructure, which is read-optimized stores, that helped us get through some of these scaling challenges over the years. And in order to talk about this piece of infrastructure, I'm going to zoom in on one specific part of Airbnb's product, which is the Airbnb listing page. Cool. So for anyone who's used Airbnb before, this page might look familiar. And for anyone who hasn't, this is one of the most important pages in Airbnb's product because it's where guests go to sort of like browse all of the listing related information before they book. So for example, on this page, guests can browse things like listing photos, they can read reviews, they can read listing information, they can also look at like pricing and availability. So let's dive into sort of what the architecture would look like behind this page. Oh man, it looks like my formatting got a little messed up, but that's okay. So if we look on the left, there's a picture of the Airbnb listing page. And on the right is an example of what the architecture can look like. So starting off in the early days of Airbnb, what the architecture might have looked like is you might have a web server that receives requests from clients. And then the web server would call into a single database containing everything. It would then get the response and then generate a response for the client. So overall, a pretty straightforward and pretty simple architecture. Over the years, as Airbnb's product grew more complex, the architecture evolved as well. So instead of calling a single database, the web server might first call a listing database, where it might look up listing-related information. Afterwards, it might call into a user-related database to look up things like superhost status or user profile photo. Next, it might call into a reviews database to look up reviews information. And lastly, a pricing database to look up what price and availability we should show users. In general, we call this model an in-memory join, because a single web server essentially calls all these different databases, gets the data back, joins it in memory, and then returns it to the client. And this is the model that most services at Airbnb follow. And for the most part, it works pretty well. It's simple. The web server just looks up the data that it needs, and it returns it. I think where you can run into some challenges is if you have certain high traffic or high complexity pages or services, then this model can run into certain issues. And I'd like to talk about those next. Cool. So looking at a couple challenges that you can run into. The first one is around reliability. And oops, sorry, I went ahead. Yeah, so what are some challenges you can run into with reliability? Well, essentially, when you're calling all these underlying data sources, if any of those calls fail, your web server might not be able to generate a response, and that call might fail as well. Latency can be an issue as well, where basically, the web server has to wait for its slowest dependency to return before it can also return a response. Historically at Airbnb, this has actually been a problem with availability, where you can have like many complex overlapping sets of rules around like booking windows, minimum booking lead times, just many different sort of restrictions around whether or not we should show a listing as available. That can be pretty complicated to calculate. In general, these can also be difficult to cache, as like guests can search by many different dates, different guest counts, and those can all impact availability. One last challenge you can run into with this in-memory join model is you might have teams like the reviews team or the messaging team that want to support features like free text search or searching across databases and tables. And in general, certain native database implementations like MySQL might not support this kind of feature very well. One thing to mention also is that this is a very simplified architecture. In reality, Airbnb's architecture looks more like this. And you can imagine sort of like as the number of dependencies grows, these problems just kind of get even more out of hand. Cool. So what's the solution to all these problems? Well, one solution that teams adopted at Airbnb over the years is this pattern called materialized views. And I'll talk about how those work next. So again, here's our in-memory join model, where we have a single web server that calls into multiple databases, gets the data back, joins it together, and returns it to the client. Under a materialized view architecture, instead what we would have is you would set up an indexer service that consumes mutations from databases and basically looks up any other data it needs whenever a write happens. It would then pre-calculate a document that contains all the data that the page needs to load and store that in some sort of storage that we call a materialized view. Some examples for this that might sound familiar are like Elasticsearch is a pretty commonly used one, or Redis, like key value store, but you can kind of plug and play anything that you want. So the whole idea with this architecture is that later on, when the client makes a call, to the web server can directly call the materialized view. And one way you can think of this is that in the first model, in the in-memory join, sort of all the calculation and computation happens at read time, right when it receives the request. In a materialized view architecture, anytime a write happens, this indexer service basically pre-calculates all the data needed and stores it in the view so that when you actually serve the request, it can be very fast. Yeah. So over the years at Airbnb, we saw many teams sort of adopt this pattern, just like all around the company organically. Like they had very expensive pages to load, and naturally this was a choice that they, I guess a pattern that they chose to adopt. However, they also started running into problems, and I'll talk about this next. Cool. So one challenge that teams ran into while building these materialized views is that they each had to, oh man, this got messed up too. Sorry about that. One thing that they all ran into is that they all had to implement their own custom consumer logic. So basically, like they each had to write sort of listeners for each database. They had to write their transformation logic within their indexer service, and they had to write their own sort of custom adapters to write into materialized views. Teams also in general had to create mechanisms to handle versioning and concurrency. Basically, like race conditions can occur across separate databases from simultaneous writes, and you need to handle that so that you don't overwrite your view with older data. And some teams just completely chose to ignore this. One last thing that teams ran into was sort of a way to basically, like we have the indexer service that's online and it streams updates, but we still need a way to populate the index with the initial data, kind of like when you first spin it up or if you make schema changes. So basically, teams implemented online and offline jobs in order to bootstrap their indexes, but they all ran into various problems as well. In general, there was a pattern. Many teams at Airbnbs wanted to utilize materialized views, but they ran into difficulties basically in building and maintaining these services. And overall, it was just very painful for them to sort of maintain this. It was also around this time that people on my team noticed these patterns, and this is exactly where the read optimized stores framework comes in. Cool. So the goal of the read optimized stores framework, or as we call it, the ROS framework, is exactly to solve the problems described earlier. Basically, we try to provide simple building blocks to enable people to build these materialized views in order to solve their product use cases. So next, I want to talk about how the ROS framework works at Airbnb. And to do that, I think the easiest way will be to showcase kind of like if we were clients, how we would build a pipeline. So I'll jump into that. Cool. So this is the listing page from earlier, and we're going to use this example again. The first thing clients would provide is a GraphQL query that should contain all the data that they need in order to render the page that they're trying to build. So for example, if we're trying to build a materialized view for the listing page, we might want to include information like the listing title, or pricing information, or reviews information. We chose GraphQL specifically because this is a language that many of our client teams were familiar with. Many of them are more product-facing teams, and in general, Airbnb, most of our APIs are implemented in GraphQL. So this was a language that we thought would be most familiar to people and help them onboard quickly. Cool. So after writing the GraphQL query, clients can also optionally provide business logic that can be used to sort of calculate aggregate or derived fields. And one thing to note is that we take this GraphQL query and generate a Java object with the exact same shape that clients can then manipulate. One example of something that you can do in the business logic is, for example, with the listing page, maybe you want to take the reviews and calculate an aggregate review score in order to show guests that are browsing the page. And this is the sort of thing that can happen in the business logic. Cool. So that's pretty much the client interface to ROS. Let's take a look at what happens under the hood. So the first thing that happens is the ROS framework takes the GraphQL query and business logic provided and generates an online stream job that basically consumes updates from the databases and writes it to the sink. So we refer to this as a ROS pipeline, or read optimized stores pipeline, because it takes input data from one side and outputs it to the other. In terms of the input data, again, it's database mutations from the databases earlier. And what the ROS framework does is it takes the GraphQL query and it generates consumers that knows exactly what databases to listen to and sort of what mutations apply. From there, we call back into database replicas in order to fetch any additional data needed. Then we take the client business logic and basically apply it in a transform step we take the data returned in the earlier step, we apply the client transformations in the business logic, and lastly, we write it to the sink. And so summarizing, putting this another way, essentially clients provide us a GraphQL query in business logic, and we generate them a real-time streaming job that consumes from databases and keeps the sink up to date with those mutations. There's also one missing piece, which is on the offline side, like how do we bootstrap the index? And the ROS framework handles that as well. So instead of consuming from databases, we consume from database snapshots in our data warehouse using Apache Spark. So using the exact same interface of GraphQL query and business logic, we first generate a batch query using the GraphQL shape, and then we run the exact same pipeline logic and basically backfill the results in bulk into the sink. So summarizing again, basically clients provide us this query and business logic, and we not only generate them an online job, but they get an offline job for free as well. So that's the majority of the architecture for the ROS framework. Other things that clients get when they use the ROS framework are, for example, a standardized set of dashboards and alerts. Here, for example, is one sort of shared dashboard that clients have access to. And you can see on the bottom left, we have some metrics around how many database mutations are we processing. And on the bottom right, you can see a metric for end-to-end lag, which is whenever a database mutation occurs, how long does it take for the data to be propagated into the sink? One interesting thing is that this particular dashboard is actually used for capacity estimation. So you can see kind of midway through the mutation events diagram that there's a big sort of jump in these yellow events. And what happens in the capacity diagram is the blue line is current usage and the purple line is max capacity. And you can see that we actually start exceeding the max capacity of what the pipeline can handle. As a result, on the bottom right, then we see propagation lag start to jump. Yeah, so in general, we use Datadog pretty heavily for these sorts of like metrics and monitoring and dashboards. One other thing that we provide to clients is alerts. So we make pretty good use of Datadog monitors, and most clients have these enabled as well. Cool. So that's an overview of ROS architecture. Next, I want to dive into one specific challenge around concurrency that we ran into, and maybe this will be interesting to people. So to talk about this, I'm going to start with one example race condition that we ran into, and then I'll talk about how we solved it within the ROS framework. So in this example race condition, let's say that we have two databases. We have a listing database, and we have an availability database. And the availability database contains an initial value of false, meaning that the listing that it corresponds to is unavailable. And let's say that we have two threads, and we're going to look at a timeline of events for what happens. So let's say that at time 1, there's a listing mutation. And what happens is the listing mutation is produced by the database, and it's consumed by thread 1. And at that time, thread 1 will call into the availability database and read the value false, and it'll store this in memory. So listing ID 1 has is available set to false. Jumping ahead to time 2, let's say that the first thing that happens is thread 1, for whatever reason, goes to sleep. So it's just sitting idle. And at this time, let's say that there's a simultaneous update in the availability database setting availability to true. So like, let's say the host just basically set their listing to available. At this time, the second thread would receive the availability mutation and call back into the listing database and basically store in memory listing ID 1 with is available as true. So jumping ahead to time 3, let's say that the first thread is still sleeping, and then the second thread writes this data into the sink. So one thing to note is that the sink is now correct. It has is available as true, and this correctly reflects what's in the initial database. However, I think some people can probably see what's about to happen next. So let's say that at time 4, again, thread 1 wakes up, and at this point, it still has is available set to false, and it writes this to the sink. Well, now we have a problem, because the data in the sink is incorrect, and if anyone reads this, they're going to get incorrect data. So how do you solve for this? I'll talk about how we did it within ROS. This is the architecture from earlier that showcases a ROS pipeline, but it's actually not totally correct. In reality, ROS actually supports two types of pipelines, which are source pipelines and notification pipelines. Zooming in on source pipelines, the sole purpose of source pipelines is to read from databases and generate what we call notification events, which are basically Kafka events that it writes to a Kafka topic. The notification event contains one single field, which is called a document ID. And this is the ID of the eventual sync document that'll be updated. So the notification pipeline reads these notification events. And the first thing that it does is it takes the document ID and looks up any additional data it needs from data replicas. And then from that point, it applies transformations and it writes this document to the sink. And again, you can see the document ID here, which is a unique identifier for the document in the sink. So one way to think of this notification event is it's basically a way to tell the framework that some update has happened and that the framework needs to go and refetch all the data associated with this document ID and just update it in the sink. One other thing about this diagram is, in reality, most ROS pipelines consume from more than just one source. So you might get something like this, where each of these source pipelines is auto-generated based on that GraphQL query from earlier, but reads from an individual data source, publishes these notification events, and then writes that data to the sink. One really nice part about this architecture is it really simplifies each of the components of the pipeline. So the source pipeline's only purpose is to take whatever database they're listening to and map those mutations into document IDs. And then the notification pipeline, regardless of where the mutations are occurring, all it needs to know how to do is take a document ID, rebuild the full document, and write that to the sink. Tying this back to earlier, the concurrency problem, the way that we solve that is that it's actually pretty solely based on the usage of Apache Kafka. Basically, within Kafka, we can partition the topic by document ID, which will essentially guarantee that all updates for one single document ID are only processed by a single thread. And then we can basically avoid all the sort of concurrency problems that were described earlier. One last thing I'll mention is that whenever the notification pipeline starts processing the events, we also stamp the event with the current timestamp, and we store that as a version within the sink. This is really useful when you have multiple things writing to the sink. Like, for example, when the offline backfill job's writing to the sink, you can basically do a version comparison and guarantee that it's never overwritten by older data. And there's no more content on this slide. That's all the content. So yeah, that's pretty much an architecture overview of how we solve for concurrency and versioning within ROS. Cool. So yeah, I guess for this next part, I'll just quickly cover some current adoption within Airbnb. We currently have about 25 teams using the framework with over 80 materialized views or indexes in production. Across all our ROS applications, we handle over 20,000 events per second. And in general, teams adopting both ROS and materialized views see very significant improvements in reliability and in latency. For the last part of the presentation, I want to talk about some learnings that we had. The first learning is that basically, investing in interfaces has had a huge impact on developer productivity for us. Specifically, our interfaces of the GraphQL query and clients providing business logic is basically, it's something that's very familiar to clients, and it's allowed them to onboard pretty quickly while allowing us to make significant changes under the hood without impacting them at all. In general, working on a platform team, we feel like it's been really valuable to invest heavily in the right interfaces early on, since this not only has helped us improve customers' experiences with our products, but also helps us keep our code more maintainable in the long term. So we've been happy with our code interface, but one area that we have been trying to work on more is around our ownership model, and I'll dive into that next. So the learning here is platforms enable scaling, and I'll talk about what that means. So this is, again, kind of a simplified picture of our architecture from earlier, where on the top we have a client indexer service that consumes from databases and writes to the sink. And then on the bottom, we have your offline bootstrap job, which consumes from the data warehouse and writes to the sink. So one thing to mention is that right now clients provide us this client logic, and we generate all these components for them. But afterwards, in reality, all of this becomes owned by clients. So they're responsible for things like monitoring metrics, responding to alerts, and basically all the other aspects of ownership. So when we first created ROS, we made this assumption and intentionally kind of set up this ownership model where we would generate them components and then they would own their services. And this was because we made the assumption that client teams had more sort of product context or like domain expertise, and that they would be better suited to define their joins, configure their services depending on the traffic patterns that they have. Like we assume that because they have this product context, they would essentially be better suited as owners. But in reality, I think we've been realizing that this ownership model is a mistake over the last couple of years, or maybe not so much a mistake, but that it's difficult to scale this ownership model in the long term. Like clients have this sort of context on their products, but in general, to operate like a stream processing service, there's a lot of additional context that you need that our clients don't necessarily have or like want to learn. Some examples include figuring out how to properly tune Kafka according to the traffic that you have, or on the offline side, like tuning Spark. Or kind of another one is making sure that your offline bootstrap job doesn't compete with your online job for resources, because then like a backfill job could sort of block out your online job from processing updates. So anyways, we've been running into challenges with this, and we have a plan to try to improve this in the future. And the plan is that instead of clients owning a single indexer service, we're planning on building sort of like a ROS platform on the online side and a shared offline job where sort of similar pipelines where clients still provide us, they essentially provide us their logic and we generate the pipelines. But the main difference is that we overall own the architecture. We sort of guarantee them that their data will be available, but we own all the operational aspects. And we think that this will help basically more people onboard, and it'll help scale ROS in the long term. Tying this back to the learning, platforms enable scaling. I think this is sort of one pattern that we've seen in general at Airbnb over the years. Like I remember when I first joined, teams would, for example, if you're on a team, you might need a database. And so different teams around the company would all, have to provision their own database, pick exactly how many resources they needed. If they got more traffic, then they had to basically manually scale up their database. They had to understand like the cost implications. And you get to some point and there's 50 different teams doing this, and it doesn't make sense anymore. It makes more sense to create a centralized storage team that can sort of handle all these complexities and just expose an API and then have all the other teams around the company just use their API and not have to worry about how many additional whatever resources I need to scale my database. So this is a pattern that we've seen at Airbnb, and I think is pretty common around other companies as well. And that's a pattern that we're planning to adopt with ROS. One last learning that we have is that under the right circumstances, materialized views can be a pretty powerful tool. For example, this quote is from Ali from the Airbnb payments team, and it's from a blog post posted in June 2022. Basically, around that time, they migrated several payment services onto both the ROS framework and just starting to use materialized views in general. And you can see they saw some pretty crazy improvements in both latency and reliability. Yeah, so I think over the years, Airbnb's product has really grown and gotten more complex, and materialized views have been a pretty useful tool to let us sort of continue to build on that complexity and add more features while still keeping the customer performance pretty good. So yeah, in general, they've been pretty useful at Airbnb, and we hope that they can be useful for you all too. And that's the presentation. So yeah, if I can say one more thing, if that's okay.
Go ahead.
First, yeah, thank you all for listening. Thank you for coming. If anyone's interested in learning more, you can check out our engineering blog. We actually recently published a post on the ROS framework, and we'll probably publish more. One thing is we use our internal name for the project, which is Riverbed, so in case anyone finds that confusing. If you're interested in careers, please check out our career page. And if anyone wants to chat in general, please shoot me an email or message me on LinkedIn, and I'll try to get back to you as soon as I can. So, sorry, thank you.
That's perfect. You have to always put that career page. Good. So thanks, Victor, for the presentation. That was super, super interesting. We have one question in Slido, and then we are going to switch to the room. The question is, certain type of data storage have native implementations of materialized views. So what was the main reason why Airbnb opted to build its own solution?
Yeah, that's a great question. Yeah, so certain databases, like I think SQL Server has, in other databases, have a built-in materialized view feature. One thing that Airbnb needed to address is, different teams across the company use different types of databases. Like MySQL is common. We had key value stores we needed to support. We have an in-house thrift store. Teams wanted to consume data from Hive or offline. And the sort of existing products didn't support these use cases well. So this kind of happened organically. Teams realized this early on and built their own solutions to consume from all these data sources. And the ROS framework was just an evolution of that. Yeah.
Great. Any questions in the room? Yes. Okay, we got another questions on the Slido. How do you handle multiple mutations to the same record being funneled into multiple views? Parallel event consumers or something else?
Yeah, in general, each of our pipelines is run in sort of an isolated setting from each other. That's a great question, whoever asked. Yeah, it's kind of one nice part about our current architecture is that sort of by default, each pipeline's isolated from each other. So it's hard to explain, but in general, our database mutations also arrive using sort of an in-house CDC bus based on Kafka as well. And so Kafka handles sort of making sure that each consumer group correctly receives the message. And then from there, it's separate. It's a separate pipeline on a separate service, so it's not too much of an issue.
Good. Any other questions? Yes.
Thank you. Your GraphQL mutations, are you getting those from Apollo Server? How are you actually getting those registered?
That's a good question. So for Airbnb, let me think about how to say this. We use GraphQL kind of at the presentation layer, but we don't actually use GraphQL at the database layer. We have a sort of a separate schema language across the company. So in that sense, the mutations that we have, they're not actually based on GraphQL. I mean, I'm not sure how much detail to go into, but like basically we consume bin logs and produce sort of like thrift mutations based on that. It's not actually, yeah, they're kind of separate. Like within ROS, we use GraphQL purely for the code generation aspect, and it also ties into our API layer that we can use to do some nice things, like we can share tooling with them as well. But yep, great question.
Where did you handle the obfuscation of any PII or auth-related data? Because now you have two copies. One there is source of truth and the materialized view. And also, what's the retention of your materialized view? Are you frequently purging it, or it's a long-term history?
Yeah, I'll speak to the second one first, which is the retention. It kind of depends on the data store, but in general, most of our materialized views don't have an expiration. That's not true, actually. I'll give you an example. So many of our clients use Elasticsearch. That one doesn't, like, we don't expire records from Elasticsearch in general. They kind of just stay until they're either overwritten or deleted. You can also, we have like a key value store, and teams do configure like sort of an expiration for records based on what they want there. So it kind of depends on which materialized view you want. And one nice part about the framework is as long as you sort of meet the interface or protocol that we set, then you can adopt it. Going back to the first question around PII, I think it's sort of handled, I want to say upstream of us. Not sure how much specific detail to go into, but yeah, like luckily it's something that at our schema layer, we have this tagging that allows us to say, you know, these fields shouldn't be propagated or these ones should. And yeah, it's luckily a lot of it is already abstracted, kind of. So.
Any last question? Okay, thanks, Victor.
Yeah, thank you all for attending.